So good afternoon, everyone. Welcome to day 3 of the conference. I think we are having a great talks. We have several very interesting talks yesterday and day before that. So what we are finding is that the interaction from the participants is slightly lesser. So I would request all the participants to ask more questions and engage the people. You can either put your questions in the chat box or we will unmute you at the end of the talk and you can ask questions. We get more from the speakers than what is being covered in stages. So with that, let us begin our day today. And again, this is a reminder that we have a nice discussion session towards the end of this conference at 6:10 local time. So again, please be ready with the suggestions, and we can at least take them up and record them, see how this can be followed up. So with these as my comments, I would now request Professor to take over the session here and conduct the discussion. Over to you.
Okay, thank you, Professor Agarwal. Namaskar, as we say, and good morning, good afternoon, good evening to people from across the globe. We are starting our third day, and we have 3 great talks organized. As you may have noticed already, that we have 20 minutes time for each speaker, followed by 5 minutes of question answer. If you have questions, it will be helpful if you type them in the chat box. That way we can be ready. So without much delay, let me invite Professor Sagar Mitra of IIT Bombay to present his talk. But before that, I would love to introduce Professor Mitra briefly. Let me just give me 1 second to locate his bio in the book. So Professor Mitra, as I know, Professor Mitra is a professor of the Department of Energy Science, and he is an expert material scientist who focuses on various aspects of lithium-ion and lithium metal batteries. That's his talk today as well. He is a very active researcher, as I know myself, and he currently leads the battery research team in the National Center for Solar Photovoltaic Research and Education, funded by Government of India, and he has a very active research group at the Department of Energy Science. The group is engaged in commercial grade lithium and sodium-ion battery prototyping, and he has already formed a startup company at IIT Bombay to manufacture safe lithium-ion batteries. So I would request Professor Mitra to please give us, please deliver his lecture. Thank you, Professor Mitra.
Thank you, Professor Mukhopadhyay and Amit Agarwal. So I'm sharing my slide. Says, let me know you can see the slide or not.
Yes, we can see it.
Yeah, it is just now. Is shared? Okay.
Yes, it is visible.
Okay,
yes.
So welcome everyone for this wonderful Brics NU, that network world conference. So today I'll be talking about the lithium-ion battery and lithium-ion and lithium metal batteries. What we do and what are the expected that we can do for a collaborative way. So I have written future is in a different tone. Future we don't know. So maybe another 3 years, 2 years, everything changes. So that's why the technology is everyone is started working in this field, and things are changing. So I try to give some general understanding. So I'll tone down the technical part so that everybody understand what I am talking. And I'll show you what are the trend and what are the things we are doing and align the trend. So start with what India demands right now in the lithium-ion battery sector. So we are, if you look at the vehicle number of vehicles we are using right now. So right now we are using this number is predicted to be going like this, but due to this pandemic, this slope is slightly changed. But if you take this slope and we estimate that still by 2030 with a 28 to 30% of EV adoptions as per the government of India directions, we'll be having around 3,000 K cars will be used as a EV. And this is the calculation done for the four-wheeler only, not two-wheeler and three-wheeler. But just to give you, if you are taking a very small battery size like 40 kilowatt hour is a very average size for the electric vehicles. And that's the size we are expecting India is going to adopt. And that size, if you look at it, how many batteries or what are the capacity of batteries required for 2030, that number is coming to around 120 gigawatt hour. So this number, maybe you may not understand what is the size of this battery capacity is required. I'll give you one example. That's the example I've given. Tesla is having the largest capacity lithium-ion battery manufacturing unit, and that size is 35 gigawatt hour. So if I convert that, our requirement of another 5 years timeline or 6 years timeline, 120 gigawatt, that numbers comes to 4 times of this type of factories are required by 2030 or 2029. So that amounts are very high, but don't go with the cost. Cost is different. Costs are changing, is the dynamic. But the main thing is required is expertise. The battery, this is a different type of technology we are talking about. Expertise and the human resource. So that much trained engineers are required. So that's our responsibility to develop that type of trained engineer for this type of purposes. Okay, so next go to I'll give you idea, not doing much on technical side. This is the two size of the battery everybody uses. This is the size is called pouch and this is called cylindrical. And this everyone is using right now. So this pouch, it is there in your mobile phone. And this is used some of the camcorder or other places. And if you look at, this is I'm putting into the dimension like this is, we can see in your eyes. So if you look at inside, this is interesting. So this is the engineering starts. So how these materials are packed in this inside. This is a circular way. It is cylindrical cell. That's when it's a circular. And there is a different some hole. And this is a lot of engineerings are there. How to stabilize this for a long timeline. And this is, if you look at in the cross section, this will be like this. I'll go little deeper. So I'm talking from the very small large times dimensions to the lower dimension now. So if you look at this, the one of this, and you can see there is several colors there. You can see these colors. This the brightest color is actually aluminum, and after aluminum we'll see the black color, and that thickness is due to is called cathode. So we know that any battery will have a anode and cathode, positive and negative, and in between there will be electrolyte. And each one cell, as per the battery scientists, we say this is a cell. But if you have several cells connected, so this is called battery. So that's a nomenclature. So here, this one we say is a cell for the engineers, but this inside several cells are there. So that H combination is one cell. Here you can see 3 or 4 cells are there. In between, there is another color is coming. I don't know you can see or not. This color is due to, this is actually a separator, very thin separator. After separator, we have a anode material, which is mainly graphite. And there is a bright brown color, brownish or golden color, you can see that is the copper. This is the inside material. So if you look at this in a little bit in another dimension, you can see this is looked at as this is a separator which need to be there in between anode and cathode, not to short circuit it. After that, we have a anode or cathode material. So here, this is one dimensions. And if you look at little bit inside of by microscope, you can see the particles looks like this, because what we are doing right now, we are making this ceramics powder and putting into the electrode. Like it is like a combination of several particles which is inside this electrode. And there are a lot of things. This is the engineering part comes here. Even start from here to here is engineering apart from materials. So if you look at the materials research right now in the lithium-ion battery, goes towards the material to engineering mode. So there are a lot of porosity and toxicity. Toxicity means how the path is open for the ions to go in. So this porosity and toxicity is very important for battery operations. If you want to have a high energy, high power, in the same way you can control this porosity and toxicity so that we can have a better and better what demand you have from the same materials. And if you go a little further, even the materials to the inside, even the dimension of nanoscale, even atomic scale, you can see the crystal structure. You can see this is the separator I put it, and one side is cathode, other side is graphite anode. This is the anode graphite. You can see that atomically these graphites are in layered way. So this layered means two graphite carbon layers are separated with and there is a lot of empty space out there in the crystallographically where lithium sits. And this other case also, cathode also is this is the example of lithium iron phosphate. There is also crystallographically, there is a lot of vacant space where these small balls are actually lithium. There is a space lithium to occupy. So this is the whole structure. Now, if you see, whoever interested which domain of research, some people are interested only this, they are working on this. Some people are interested on electrode design, people are working on this. Some people are interested on making the battery out of it, they are working on it. So this is the overall, the whole set of things is inside the battery. It looks very simple, but it's not. Otherwise, everyone can do this battery research. It is not that easy. We say it is easy, but it's not that easy. Let's come, where is the problem right now? So if you look at all the combinations, so right now I said that anode is the graphite and cathode is in the mobile battery, lithium cobalt oxide is one of the, is called LCO. That's a cathode is used in a mobile batteries. Even your laptop also having same compositions. But for the for electric vehicles, we are changing the cathode composition, keeping the anode side fixed. So here I'm showing some of the composition right now is in the commercial grade or is coming up. So some of the things are showing it can go up to 400, 500 watt per kg liter. And if you look at the specific energy in the kg wise, it doesn't cross even 300. This is the extended now, it can go. So there is a possibility is here, it can go to this level. So there's a different composition of silicon, lithium rich, manganese, nickel, manganese, cobalt, this type of combination. This is a different compositions of cathode, other than that graphite is same. So if you look at this, the practical battery scenario, what we are getting the energy density in terms of liter and the volume and the gram wise. But if you look at the theoretical capacity, at the same scale, if you look at the theoretically, if I calculate the same compositions, I calculate it theoretically, it's way different, at least more than 10 times of what we are getting out of it. That's the difference. So theoretically to practically, that's the difference we are getting. So there is a lot of scope, and that's why people are working on it. Using the same material, you can go up. And people are also looking at what is beyond lithium ion. I don't think anything is beyond lithium. All are having lithium is there. So lithium ion or beyond lithium ion, you can say, which is used lithium metal. So you can see some of the composition which is uses instead of graphite silicon, they are using lithium metal. That's another things we are going to talk about it. So you can several compositions are looked at it which can exceed these numbers or whatever we are getting right now. So that's a things we are started working on the scales. So I'll give you the combinations. What are the things are right now battery trend is going on. These are the three things people are expecting or working on the research field, even they are in the commercially. One is capacity. Increase the capacity because vehicle needs a more capacity than what is right now. Safety is main concern because you know that several vehicles are catching fire during operation, during even ideal conditions. The safety is major concern. Other one is sustainability. We cannot use every element which is maybe toxic or may not be good for long run. So we need to look at that sustainability. So this sustainability terms comes right now. Another thing is maybe electrical engineer will be interested fast charging. But as a battery engineer, I am not very interested on the fast charging because I know what is happening inside the battery. So in the cell, overall maybe you cannot see, but inside the cell what is happening, I know. So these are the things people are working right now to keep this safety, capacity, and the sustainability. And people are shifting towards carbon to silicon. That's I'll give you some of the examples what people are doing right now and what we are doing right now. So one concept you may know, one concept people are started talking about is anode free. This is a Tesla's concept, anode free. I already talked about it. Current batteries using graphite as anode and LCO, lithium cobalt oxide, as cathode. But they are talking about one thing is anode free. What will happen if you remove the anode as a graphite? So if I remove the anode, let's say I have started using the current collector is a copper current collector and only graphite, only LCO as a cathode, and I start charging. We know when you when you buy a battery, the provider will ask you to charge the battery first before use. Why? Because they need to store more and more lithium on the anode side. What is happening during the charge? This charge, the lithium is there in the cathode side. That lithium goes out and goes deposited on the graphite side. Here, what I am doing, I am remove the graphite from the anode side. So lithium will deposit on this copper surface in a very thin layer, in atomic layer, deposition will start. And once that happens, so after charging, this battery is complete now. Now lithium act as a lithium metal anode, and other side is graphite. So another side is LCO. And again, discharge, this lithium will go out and then go to the cathode structure. This is well known. So what I am getting benefit if there is no graphite, I am getting the weight advantage. I am not using that graphite weight, so that this is I am increasing the energy density. How much charge is there, that depends on how much lithium are exchanging. So, but in the terms of charge divided by weight of the battery is reduced because I am not using the anode. So that's the one concept people are trying. This is again R&D scale. Everybody is looking at how to solve this problem. There are several problems are there. Other one is called million miles battery. You may know this terminology is called million mile battery. This is same. Million battery also have the same concept, anode free. Instead of this lithium cobalt oxide, this is used as a polycrystalline because there is a several crystallinic plane are there. Instead of polycrystalline, if I use a single crystals, so same material with a single crystal form, what we observe, the single crystals doesn't break during the charge and discharge, even I charge and discharge. So that if doesn't break or doesn't degrades the cathode material, we may expect that it's the reactivity is lasted longer time. And that's again, that is again the speculation that can go even thousands or maybe lakhs, let's say 10,000 cycle life of the batteries. So that's why we call it million batteries. But these are all concepts, still not commercially available yet. Another concept is, I'm giving a concept on what we are doing. This is the things we are also working on right now. This is another thing, same thing, same electrode. So if I make the electrode in a isotropic way, so like right now what we are doing, you are using the particles, this is the particle size, are not uniform, is all at different sizes. I'll show you what actual picture of the particles. Take the same electrode, but if I have without not having a non-uniformities, having a all uniform, same size, same shape. So what we predicted that this surface reactivity enhances 2 times. So that is another angle. So if I make this particle all are same size and shape, I may increase the reactivity, surface reactivity 2 times. This is theoretical predictions. There is a possibility that I can enhance the further the same electrode, same materials. Don't have to do further, but this is challenging. Right now, if you look at, this is the actual LCO with their size is not very uniform, is anisotrope is there. Even graphite also certain size are almost same, is like a similar what we are predicting. So this cathode with whatever cathode we are using, if I can make this in a similar size, similar shape, some of the research are already there. They are making it, but these are actually again going to a very costly affair of the synthesis, and sometimes may not be possible in a large scale. That's the things another research area is coming up for the material size guys. But once you make this in a electrode, there is this same electrode, you can see there's an electrode inside is a cross section feed like a focus and beam cross sections that looks inside the electrode how the particles are. This is not similar in size, and that's why you can have a different toxicity and porosity. So this is another active area people are working in. Even for the advanced electrode design, this is another area people are working right now. Another area of research is, instead of graphite, can I use silicon? Silicon is one of the component people are looking at, because silicon can store lithium 10 times more than what graphite is. Graphite, if it is 300 kg ampere hour per kg, silicon can make 3000 ampere hour per kg. So that much energy can be stored if I use silicon instead of carbon. But it's a lot of problems are there. Here we are doing, we are making silicon from sand, and that is a very short-term process we have used. And this target of our idea about this silicon can be used in a larger scale. We have already done this for a smaller time scales, smaller dimension. You can see there is a one demo is going on, but we are trying to make this the same composition of anode. Can I compound with NMC and get it around 300 watt per kg? That's a target right now for electric vehicles. Even Tesla is trying to have 300 watt per kg. So to do that, you can see that if I look at, if our calculation says that if you have a capacity about 750 kilowatt hour per one side, we may achieve. So we have almost achieved that 280 kilowatt hour per watt hour per kg of things. And once we are achieved around 700, we'll be going for a pouch cell or making a large scale making of cells. So that's our targets. Another things I talked about, lithium metal. So instead of graphite, can I use lithium metal? That's the things people are working right now. So lithium metal having a problem. Once I use a lithium metal in the anode side, there is a lot of dendrite formation, because lithium doesn't deposit in a uniform way. So there is a dendrite formation happens, and that dendrites creates a lot of problems in the battery system. And there is another solutions we are doing. We are depositing some of the component from the ACI, which is lithium surface film formations. We are taking that composition and making artificially, and seeing that these compositions are good for your long cycle life. Some of the cycles of 10,000 cycles are in a miniature time scale. You can see this is possible. So another problem of lithium battery right now, this lithium battery cannot be used at lower temperature, let's say 10 degree or 0 degree below. So that creates a lot of problem, because liquid electrolyte is not, whatever composition you are using is not correct for the low temperature of operations. So there is several things are going on right now in the liquid component, replace the liquid component by some components. So here also we started working on the different compositions, which composition shows that this we can do the cycling of the battery at minus 30 degrees centigrade. This is another things we started working on it. So another proposition worldwide going on, the solid state electrolyte is a electrolyte for the liquid, replacement of liquid. You can see some of the graph shows that some of the electrolyte of solid electrolyte is the compositions are okay even from very sub-zero temperature to a higher temperature. The conductivity keep on, there is not much changes. Instead of liquid, if I use liquid, whatever currently you are using, it doesn't have electrolyte conductivity at that lower temperature. That's the reason it is not used for, it is not operating at the lower temperature. So that one proposition was, if we have using this solid electrolyte in the battery, and that can operate at lower temperature. It operates theoretically, but it's not in the practical sense. So right now, all research are going on. Even we also have a lot of research are going on in this. We have a particular architecture. We can have same silicon we have used, and you are seeing the stable, getting the stable capacity with the solid electrolyte composition right now. So we are right now developing some of the this technology, putting into the larger scale, and see how we can be getting battery out of it. Another direction is, we know that this battery, once you pack, it is very difficult to understand what is happening inside. This is some of the experiment need to be done to understand the stability of the material, what is inside, how the things are changed. So here I am giving some of the examples we are doing. This is in situ Zan's experiment are done. This electrode also made, designed by us. Right now we are using in RRCAD indoor facility. This is a world-class facility which is used, and to see during cycling without opening the cell, how we can see the crystal structure difference, like how the crystal structure changing or not changing. So that will give you idea about the any technology, how far it can go without changing the crystal structure. Another thing we are working on in situ Raman spectroscopy to monitor. This is for the sulfur batteries. We can see that is also seen with the different cycle charging and discharging, how the structural change is happening. So this is done with, this is the experiment which India is still not done. we have done in with collaboration with Northwestern University. This is tunneling electron microscope study in situ mode. So some of the electrodes are made in a TM plate, where you made the small cells and see the structural evolution during the cycling. So that can be monitored in an atomic scale. That's the things is a very strong research is going on in these directions for the advancement of the batteries. So we always talk about, I may have 1 or 2 minutes. Okay, so everybody talks about road transport, but the electric mobility also goes to the air transport. So when we talk about air transport or road transport, small vehicle to larger vehicle, the energy density is more for the smaller vehicle, larger vehicle to come this. But when you talk about the drone application, like a passenger drone, these things are completely different. You need a more energy as well as more power. That's a completely different zone. Why is need? Because when you have a takeoff and the landing, both cases power is very high. Power requirement is very high. So if you look at all the composition right now, what we are having the composition which can match this power plus energy, there is some theoretical calculation says that it is possible. Some of the compositions can be put in this, and there's a lot of directions going on. Research is going on in these directions to power this type of vehicles which can carry 2 to 4 people in a year. So that type of research is going on, but there will be limits. So if you look at drone, maybe can be taken care by battery, but when you go for a real aviation, like aviation side, like a narrow body airplanes or wide body airplanes, their energy demands are very high. So battery can go up to this, what electrochemical storage we know, which can have that much power, can go up to 500 marks. So that means shows that currently whatever knowledge we have, that may aim up to drone level, not more. So battery cannot solve all the problem for society. So that also you need to keep in your mind. Okay, so in our research in IITB, we do a lot of prototyping. So what are some of the things we have in the 6th level, tier level 6. I have on startups. So that shows we are making some of the electrode design, and we say that this is ultra safe because this anode structure doesn't create a dendrites. I'll give you a demo. So this is the commercial battery. Don't do this experiment. If you charge and put a nail, you'll see there'll be blast. But this is the same conditions. We charged very deep discharge at very high rate, and you are slicing the battery. There is no catching fire. And this catching fire incident happened because there is dendrite formation, heavy dendrite formation inside the battery in the anode side. But our technology doesn't match that. So that's the things we are proposing, and this technology is well proven. We are putting into the even vehicles and trying it in a 2-wheeler right now, and we'll be going, if it is successful in a 3-wheeler, we'll be going for a manufacturing of this. Thank you. This is my team, and thank you very much for the opportunity. And only last point to discuss: energy density has increased factor of 4, and it took 200 years. If you look at lead acid battery to lithium-ion battery, the enhancement is 4 times, like 50 to 200 right now. And we are expecting 200 to 500, maybe another 5 years, 6 years. So if you look at the old time scale, it took say 200 years. So now we are expecting the same 4 times higher capacity or efficiency by 3 years or 5 years. We need to look at it. Thank you very much. I'm open for any questions.
Yeah, thank you, Professor Mitra, for this wonderful talk. We do have 2 questions for you. The first question is from Dr. I think his name is Dr. Avijit K. The question says, could you explain briefly why silicon has 10x better capacity than graphite?
Okay, so not capacity, I'm talking about anode capacity. I'm talking about, because if you look at only single anode wise, lithium graphite can take 300 or 350 right now, and silicon can take, because of their reactivity, each silicon can take 4 lithium. So if I divide it by the molecular rate, we can have a 3,300 theoretically. Even experimentally, we also get around 3,000 ampere hour per gram. So that's why I'm saying 10 times higher. But practically, when you make the battery, anode side is 3,000 and cathode side is 200. So there is a huge disbalance of the capacity. So what we say, it is called matching. We have to match the weight of the material. If I take 3,000, I have to use at least 15 times thicker cathode. That's called balancing of the cells, and that is very difficult.
Right. So we do have time for just another question. So there is, I think, Dr. Abhishek Ranjan, who is asking that do you see the lithium-ion battery being used for large-scale electrical energy storage at the grid scale in the long term? That's the question.
Yeah, so lithium-ion battery for electric vehicles, we say this is the first life of use, because electric vehicle uses demands are very high for power and the energy. But when the first life is done, we predict for second life, let's say 5 years of electric vehicles, another 2 years for energy storage. It is happily can do that because electric storage, like energy storage, doesn't need that much peak type of like a performance based applications. So there we are predicting that second life will be for the energy storage. And third life also people are predicting, but I don't believe third life will be there. For second life is enough, and then battery will go for the end of the life. And after end of the life, we are thinking that can be recycled back. The element, all the elements which you are right now looking for can be recycled back to the battery manufacturing, the new battery manufacturing. That's a prediction right now. People are working on that directions.
Yeah. Thank you, Dr. Mitra. Wonderful talk. Thanks again.
Thank you.
We will have to move on to the next lecture, and the next lecture is by Professor Johann Hubert. Professor Johann Hubert is a full professor in the department of Industrial and Systems Engineering, University of Pretoria, South Africa. He is affiliated with the Center for Transport Development as well. His research is in the area of behavioral transport modeling using agent-based simulation. His focus is on understanding and modeling the behavior of different urban road users, particularly urban freight. So we have this paper whose title is Establishing an E-Mobility Baseline. So I would request Professor Hubert to please present his lecture. Thank you, Professor Hubert.
Good afternoon, everybody, and thank you very much for the opportunity. The conference organizers, thank you so much. Let me just share the correct screen. Right, is that clear?
Yes, very clear.
Good. Thank you very much for the opportunity. Yes, I represent the University of Pretoria and specifically the Center for Transport Development. And for us, it is a kind of unique step forward as a multidisciplinary center where we represent civil engineering as well as industrial engineering. And we also work fairly closely with our mechanical engineering department. So what I would like to share in this presentation is some of the work that we've done specifically with regards to laying the foundation and actually prepare the South African environment in terms of electric mobility, both for private vehicles, but my interest is very often also in terms of urban freight. So if we are serious in terms of the adoption of electric mobility, then what we realize is that we have to be very careful to not come over to the general public and to the industry as if this is kind of some technology push approach. And we have to find a way that we can really show that there is a demand pull opportunity for electric mobility. And especially in a country like South Africa, and I think many other developing countries, especially when there's economic inequality, then it becomes very important in evaluating these type of environments to answer two types of questions. And the first one is, who will get the benefit of infrastructure or an intervention related to e-mobility? And while this is an important question, the flip side of the same question is equally important and as hard to answer, and that is, who will pay for that benefit? And I think it's extremely important that in terms of advisors to government, that we make sure that these two hard questions, that we don't just answer them superficially, but that we actually answer them sincerely and with evidence. Now, in doing that, what we've realized is kind of from experience is that we do not have a shared vocabulary. So if we take this simple word such as transport planning, and you can add different forms of subdivisions like e-mobility or public transport or freight, when it deals with transport, but what we've realized is that this means different things to different stakeholders. And it's important that we appreciate this difference if we want to make progress in terms of introducing something as, to some extent, radical as e-mobility. So when you take this term and you present it to civil engineers, they would typically hear infrastructure. Just close, there's something in my way. They will hear infrastructure, and they will think about roads, they will think about bridges, the land use, the infrastructure related to electrification and charging stations. But when you take the same term and you give it to industry, and my background specifically is industrial engineering, then they would typically think about it from the point of view of operations, which is a lot more kind of shorter term. Now, the best analogy that I could come up with is that it seems that the designers of the board on which we play our game seems to be ignorant to the rules of the game. And what I mean with that is, on the one side, the people who designed the board on which we play this transport game, government, they are the custodians of the board. And they typically try to plan for everybody. They try to plan for a larger stakeholder group, whereas industry and the operations, they play the game. Let's call the game logistics, or mobility. And they have very or much shorter term decisions that they want to answer. They want to know where to put the warehouse, what size fleet should they have? Should they have many small vehicles, a few larger vehicles? Should they even have a fleet? Should they insource or outsource? What should the routing of their customers be? So they think a lot more short term. And from a business perspective, it's easy to understand how a single company will try to optimize their business. But what we have to realize is that this question becomes quite tricky for government, because they have to design this board on which we're going to play mobility, or on which we're going to play road or fossil fuel and e-mobility simultaneously. They have to design this board thinking about all of the stakeholders simultaneously. And that becomes kind of fairly tricky. And I think one needs to appreciate that it's not an easy task to try and answer. So because we don't have the same shared vocabulary, it becomes then quite clear that government will tell industry, stop breaking our stuff. And when we talk about breaking our stuff, we're referring to overloading, we're referring to congestion and imbalanced road networks. And at the same time, depending on how we price the infrastructure and how we actually sell it back to the industry and our population, we find that industry will often kind of shout back and say, but stop squeezing our business. And what we've realized is that a lot of this tension actually just boils down back to these two questions. And I'm of the opinion that part of the reason for this tension is that the people who are getting the benefit of an intervention or of infrastructure are not very honest always about the benefit that they're actually getting. We find it hard to admit that we have privileged. We find it hard to actually admit that we got something and that we're in a position of choice, that we can actually exercise our choice. As but one example, it's in South Africa, it might be very easy. I think the same in a lot of countries with economic inequality. It's easy to say, yes, but electric vehicles and electric mobility is good, but the only people who will be able to afford it are your very affluent. And if you then increase this gap between the haves and the have-nots, you're actually contributing to the inequality and not solving it as part of a country's problem. So are we making any progress in terms of laying this baseline? We would like to believe so. So to address this, what we're doing is we're attacking the problem from two specific points of view. So here in this picture is an agent-based model that we developed for the city of Cape Town. So if you're not familiar with the city of Cape Town, the well-known Table Mountain is that mountain, the green mountain just below the clock. That would be Table Mountain. And every dot in this image represents a person or a vehicle, and the color of the dot represents what that individual is currently busy with. So in this case, it is 4 o'clock in the morning, and the majority of people are at home. And as the day run, and we model this dynamically over a 24-hour period, you actually see people changing their activities. Now, while I'm visualizing the activities, we also know where the people are actually traveling on the road network. And the orange dots are commercial vehicles. So this is one of the few models in the world where we always model people and freight movement in the same model because they share the same road space. So here you see at about 7:30 in the morning, there's a lot more green as the children arrive at school, which is education. And then at about 8, you see the clear work locations. The corridor running west to east is what we refer to as Voortrekker Road, which is a well-known area of commercialization and employment. And then on the left, close to the harbor, you actually see the CBD of the city of Cape Town. Now, why these type of simulation models is very valuable is because we model every individual, and we have richly described synthetic populations that we can piggyback on. And we can, when we test an intervention or new infrastructure like an added lane or a specific pricing policy, we model the impact on every individual because we know exactly where they are traveling, we know exactly what their attributes are, so we can move much closer to be able to answer or come up with answers to who gets the benefit and who actually pay for the benefit. So these agent-based models, and we work with a number of international groups, specifically it's called the multi-agent transport simulation, and it's work and research that we've been involved in for the past 10 or 15 years. So now we have a simulation tool to model very richly, and the same type of models are being used currently in Europe as well to evaluate the placement of electrification infrastructure in automobility as well as e-mobility. So it lends itself to rich scenarios that you want to evaluate. In a different scenario, up in Gauteng, and we typically refer to the province of Gauteng, which is made up out of Johannesburg, the city of Pretoria, or Tshwane, as well as Ekurhuleni, as actually a mega city, because it's 3 metropolitan areas that are tightly connected with one another, and we're looking at about 15 million inhabitants. So on the map on the left-hand side, again, you see the results of the aggregated spatial results of actually modeling emissions. Because we know where every individual traveled throughout the day, we can actually model the emissions. But in this particular case, the emissions are linked with the European databases, for example, HBEFA. And on the right-hand side, because we model every vehicle, we can also see the distribution of how much CO2 is actually emitted by each vehicle. And we can do this for light vehicles, we can do this for light heavies, which are typically your urban rigid trucks, and we can also do this for heavy vehicles. But this is only a simulation. And what we then kind of realized is, and this is where the real research and the magic happens, is if you have simulation models and experimental work that actually come together to inform one another. Because simulation allows you to capture the dynamics of the system, and you can test a lot of what-if scenarios, but a simulation is only a simulation, and it depends very much on the data. Now, in South Africa, the way in which emissions are being enforced through legislation is by ensuring that new vehicles that are being sold have got these type of stickers in their window that tells you how many liters per kilometer or 100 kilometers you can expect in terms of fuel consumption. It tells you what your CO2 emissions are going to be. And anybody, at least in South Africa, that buys a new vehicle will know that you will definitely not get that fuel consumption. And the reason for that is they do these tests, or where the homologation is being done is at the original equipment manufacturers. It's typically done at very low altitudes, and it's also done on static bench tests. And I mean, we all know about a lot of the emission scandals over the past couple of years, that these are not necessarily very reliable in terms of what really happens on the ground. So what we're trying to do is to bridge the gap from simulation and actually really understand, but how are real people being impacted? Not by what the paper says the emissions are, but what actually happens. And to do that in our research group, we invested fairly heavily, and thanks to a lot of funding partners, we invested in bringing in Africa's first portable emissions measurement system. And it is a fairly expensive piece of equipment that you actually plug onto the exhaust of a vehicle, and it allows you to measure the emissions while the vehicle is actually driving. Now, you don't see the majority of the equipment because it's in this particular case, on a light vehicle. It's in the back of the vehicle. So the student of mine, Ruan Graba, and myself, we've been running around carrying equipment for the past couple of months. And here is kind of just a video in terms of where we fit the equipment onto a urban heavy vehicle. So this is what we call it.
I seem to have lost Professor Hubert. Yes, okay, got it.
Sorry, can you still hear me? Hello?
We can hear you.
Yeah, we can hear you. Please go ahead.
Okay, sorry.
We lost you momentarily. I'm sorry.
No problem. So here we kind of just illustrate in terms of how we now take our simulation work to the more experimental level, and it's a very different type of research in terms of modeling versus experimental work. But here we fit the equipment onto a heavy vehicle, and the goal is to then drive around on standardized routes. And here you kind of see a visualization of how we do that, driving about 60-kilometer routes, typically to what they do for certification in Europe. And in real time, you can actually see and understand what the true emission quantities are in terms of the pollutants. And we believe that this is a valuable step in terms of being able to really tell individuals what the impact is of electrification. If you can not just refer back to standard international pollutant paperwork, but you can actually show, but this is the effect that you experience as a neighborhood, because on steep inclines, you will see very different emission profiles as what you see on flat areas. And high levels of congestion will impact the emissions. And for us, the challenge in terms of laying a baseline for future e-mobility is to be able to at least capture, but what is the true impact spatially and temporally in terms of emissions, so that when we evaluate alternatives or new infrastructure, that we can really make a valuable contribution in terms of evidence-based decision-making to say, this is the business case, this is why we need to consider new technology, and let it then not be a technology push, but rather a demand pull side. So that's what we've been kind of working with in terms of establishing the baseline, bring together two worlds, modeling research and empirical work, so that the two can actually inform one another better planning going forward. And with that, ladies and gentlemen, thank you very much again for the opportunity and for kind of allowing me to share some of the research.
Yeah, thanks, Professor Hubert. Very interesting. Is there any question for Professor Hubert from the audience? I do not see anything typed in the chat box. So if anybody has a question, please come up. Either type in the chat box or you may unmute yourself and ask Professor Hubert directly. I do have a question. So if there's no one coming up, Professor Hubert, this is actually a big problem, which is not the advertised fuel efficiency or even energy efficiency. It actually applies equally to EVs. That the electric range, in the case of EVs, it becomes the electric range figure, which is quoted by an OEM, and that falls drastically short when it actually runs in traffic. So the customer is actually disappointed. So how do you think we need to take care of this? Do you have a solution?
I think a lot of the claimed, and I mean, you're 100% correct that a lot of the data on which we then build these futuristic scenarios are very heavy reliant on assumptions. And our approach with these large-scale urban entire city region modeling exercises, which really makes use of the state-of-the-art, allows us to actually see, but how well do those assumptions actually hold up? If you put an electric vehicle in a real congested environment with the real road grades in terms of that it can experience in a particular environment. And again, our goal with this, developing this modeling capability, is to be able to test some of those. And what we've already realized is that even just from an emissions point of view, we see a tremendous amount of variation for any single individual over if we do the simulation run multiple times. And that is very valuable because simulation really becomes a strong tool if you can do it multiple times and get a confidence interval over many more instances, which you cannot do in practice, but you can do in a simulation environment. And the plan is to, once we have a baseline in terms of fossil fuel vehicles, to start introducing and testing the same to see, but what will the impact be on electrification? Because we know what the road grade is in terms of the steepness of the road. We know what the levels of congestion in terms of stop and start is. So the same modeling technology that we use to study the true emissions of a vehicle, we can also apply in terms of the true range of an electric vehicle. Sorry, Professor, you're muted.
Yeah. So thanks a lot. I mean, I kind of agree with what you said fully. So we have another question from Dr. Pinto. The question is, can this model be adapted to be used in rural areas and or large scales? You can probably see the question in the chat box.
Yes, and the answer is absolutely. I think a lot of effort goes into establishing these type of models. So it can definitely, in a rural setting, be used. I don't think you can get so much. Well, maybe you do get the same amount of value, but it still is a lot of effort, whether you do this for a city region or whether you do this for a rural area. There's a certain amount of infrastructure that you need to put into place. These models are generally fairly data hungry, but it is, at least it's very scalable. So the same type of agent-based models are currently being used to model the entire Switzerland, to model large city regions in the United States, and I believe the whole of Germany as well. So when it comes to scalability, absolutely, it's very doable.
Right. We have another question from Dr. K.V. Krishnara. So the question says how your model is going to evaluate the impact of introducing e-mobility in terms of emissions as well as equity.
Yeah. So typically how we would set up such a scenario is once you have a baseline for a city, you would then, using some choice model, indicate which individuals in your population will be prone or likely to actually change ownership in terms of either buying an electric vehicle or making use of shared e-mobility. So you have that choice model, and then those levels of behavior is what makes agent-based models so attractive, is that you can actually estimate those choice models, you can embed it into your agent-based model, and you can actually see the effect in terms of how those individuals are directly impacted. Now, to answer your question in terms of equity, what we observe, at least even in the studies that we're doing currently for fossil fuel vehicles, is that you can also evaluate the impact or the change of a generalized cost or a generalized utility, depending on how you kind of explain it. You can calculate the impact on every individual in the population, those that use electric mobility and those that don't use it. For example, what we've seen in studies where where people changed their mode choice, for example, from private car to non-motorized transport in cycling, you can actually measure the benefit that individuals are getting who are cycling, but you can also measure the benefit of the people who actually still travel by car, because they now have fewer cars on the road to compete with, and in the process you can actually because you model every individual agent in the entire scenario, you can also evaluate the impact on each one of them once you have a sound baseline set up. There's one more question. What are the necessary data to feed the model, and how reliable can you actually get them?
Right, sir. Yeah, sir. If I may interrupt you, we are actually running out of time. So I would request. When you can actually type an answer to this question on the chat box, and we would like to move over to the next speaker if you permit.
Thank you again for the opportunity.
Yeah. Thank you very much. It was very interesting, and the discussions. Thanks again. Yeah. So we will now move over to our third and last speaker of this session, Professor Irina Putilova. So I would like to introduce Dr. Putilova briefly. So Dr. Putilova joined the Moscow Power Engineering Institute in 1999 and is currently an associate professor. She, her main research interests are in the area of environmental protection legislation and technologies in power engineering, coal ash handling, information support of the nature protection activity of power utilities of fuel and energy complex, housing and communal services, and other branches of economy. So I would now request Dr. Putilova to kindly make her presentation. Ma'am, please.
Okay, thank you. Can you hear me?
Yes, we can hear you.
Okay, thank you very much for this introduction, and I'd like to thank the organizers of this World Conference. And I'm very happy to see my colleagues from India, from the South Africa. Some years ago, I worked in IIT Delhi, and so it was a project lasting 2 years, and I'm very happy to see my colleagues. Okay, I will start. It's like an overview. It's like the experience of our institute, of our university, Moscow Power Engineering Institute, in the field of environmental protection and climate change. First of all, I'd like to cover a little bit legal issues, the issues connected with the regulation and legislation and the concern of our government about the environmental situation. Then I'm going to present briefly about the research made in different departments and different research groups in the field of environmental protection and ecological issues. I will cover environmental education, training, school kids, festivals, and so on, and additional education or vocational education, improvement of professional skills, and professional retraining. I'd like to say that our president of the Russian Federation and our government are very much concerned about the environmental situation in Russia. And it has been developed the strategy of the environmental society of the Russian Federation for the period up to 2025. And for the time being, and since 2014, our nature protection legislation or environmental legislation has been changing, has been toughening. New federal laws appear, many of the federal laws and normative documents have been modified, and the base is the best available technologies in the power industry. If we look at the strategy of the environmental safety, we see that the clause 17 and 18, the influence of the deterioration of the degradation of environment and how it affects the health and even mortality of the population, especially that part of it that lives in big cities, in industrial cities, centers near production facilities. And economic losses are great, making from 4 to 6% of the gross domestic product, which are caused by the deterioration of environment. And so there are two main directions, two main tasks of this strategy of the environmental safety. The first direction is reduction or prevention of the negative impact from the industry on the environment, as well as the rational use of nature resources. And the second great task is elimination of the accumulated environmental damage, restoration of degraded natural ecosystems. If we are talking about coal-fired power plants, and coal ash handling is my focus of my research, we firstly think about coal combustion byproducts, and it's also a problem worldwide. And I'm the member of the Worldwide Coal Combustion Products Network, and I know that colleagues from India also participate and are part of this network. And the situation where the coal combustion byproducts in many countries is actual. I'm not going to read all the research that have been conducted in our university. I'd like to briefly mention that this activity in the field of environmental protection and ecological issues these activities have been going on at our university for more than 50 years. And there have been formed many research groups making research in on different aspects and issues of environmental protection, like emissions reduction, NOx, SOx, coal ash handling, ash removal systems, noise reduction, electromagnetic fields, and so on and so forth. And we have different research projects with many customers in the field of environmental protection and also climate change. And we also took part in the development of the reference book on the best available technologies at electric power industries. We developed different scenarios of energy consumption and carbon dioxide emissions. And so we made research on noise impact on the environment from the industry, from different facilities. And so a great amount of work. I'm not going to stop here. And we have the facilities that help us in our research projects, we use the instrumental and experimental base of the Department of Environmental Engineering and Labor Protection. Our center developed the database. It's like a platform. I'm going to tell about it later on the best available technologies in the power industry. We have the Center for Collective Use of Environmental Monitoring, different software databases that help us to carry out the project. Concerning our partners, we have customers from energy companies, from the regional heating companies, where we have collaboration with the manufacturers of power equipment, with different research institutes, with the institutes of the Russian Academy of Sciences and metallurgical companies and so on. And concerning our international partners and projects, I have already mentioned the presence of our university, of our center, of my center in the World Well Coal Combustion Product Network. And we also are members of the European Coal Combustion Products Association. And we are a part of the Russian and German project, Climate Friendly Economic Activity, implementation of the best available technologies in the Russian Federation. We have partners in Germany, USA, and Iran. And one of the issues I'm going to talk now is education in the field of environmental protection, nature protection technologies, and ecological issues. So all these disciplines listed here are connected with the ecological issues. So it could be the base, or it could be a part, yeah, of this ecological orientation issues. And so it is very important in our university, and it is of special attention now, this situation where with the environment, what technologies to use, how to teach concerning the best available technologies in the power industry. And so we I would say have many projects and activities connected with this topic. We also work with school kids, and we organize the different conferences for school children on resource conservation. We organize festivals, college education, science and production, city festivals for young generation, and university Saturdays, conduct Olympiads, lectures, and so we work with young people. And we also present at make different presentations at the technical conferences, at the House of Scientists. We are organizers of the ecological movement, Green Generation, and we prepare and publish different teaching aids, scientific methodological materials, and give interviews in this field. And now I'd like to present about the experience of my center called Ecology and Power Engineering in the field of environmental protection. It's like, so I think that we use the system or apply the system approach in our center. On the one hand, we have research and development on ecological problems in power industry with the focus on the coal ash handling. And on the other hand, we train employees of different energy power industry organizations and power plants. They get short course training, long course training, so they improve professional skills, not only in the field of environmental protection, but it's our focus. How does the system approach look like? So we conduct to make research in this field, as I have already mentioned, train listeners, employees of different companies, develop teaching aids, create different information systems like the database on the best available nature protection technologies in the power industry, and organize international events, conferences, and workshops. My special love, I would say, my special attention is devoted to coal ash handling issues. we work on normative and technical documentation to replace natural materials with coal ash. My PhD many years ago was devoted to erosion in pipelines. And by the way, in IIT Delhi, we conducted the joint project connected with erosion in pipelines while transporting bulk materials. And it was successful. It was supported by DST and the Russian Foundation for Basic Research. We developed recommendation how to reduce erosion in pipelines, curvilinear sections, first of all, and rectilinear sections, and so on. So I continue this work here. And many other things connected with coal ash handling systems are for dry systems, of course, being the ecologist. Yeah, and so the main idea is how to design economically sound, ecologically sound, economically reasonable, and technological coal ash handling systems, and with the maximum usage of coal ash as a commodity product, so for processing, not for just storing, disposing of. Why is this coal ash problem so important, so of special attention in my center? So the scale of the problem. In Russia, I can say that if we're talking about large coal-fired power plants, it's about 150 of them. We have also block stations, let's say, and for many years, 1.5 billion tons of coal ash have been accumulated. And the area of ash disposal sites is more than 20,000 square kilometers. So, and for the moment, about 70% of ash dumps are full, yeah, and no capacity, have exhausted their design capacity, and the rest part will be full in 10 years. So it's really a headache. Coal production is, according to the experts' estimation, is about 30 million tons per year, and utilization is only 10%. It's very sad. As far as I know, in India, it's about 50%, and I'm familiar with the large-scale projects conducted in different states and demonstration projects that are conducted in India. Results of educational work. So for more than 20 years, we have trained more than 1,500 listeners and developed many professional training, retraining programs. And we even got the National Environmental Award in 2007 in the category Education for Sustainable Development. Sometimes it is difficult to separate what is research, what is training, because it is connected with each other. When I train my listeners, I talk about research projects we are dealing with, and so it's all connected with each other. And of course, conducting conferences and workshop is also used when during the training process in our center. So for many years, we have developed different teaching aids on ecology, in power engineering, and environmental technologies. And one of the result is the information system, the best available and prospective nature protection technologies in the Russian power industry. By the way, the system is free of charge, and even you don't need to fill in the information, just you can visit it and download the files, the PDF files that are inside. So it's the main page of the information system. It is in Russian and in English, so the same versions, identical. And the sources of information are experts analytical materials that give the experts and that are that go to the editorial board of the system to examine if they are good or bad, whether to upload them or not. And the results of the system research we conduct and the proceedings of the international conferences and workshops we take part in or organize ourselves. So you see on your left that there are all the issues connected with the environmental protection here, like air protection, water protection, coal ash handling, complex technologies, factors of physical impact, advanced technologies, energy saving, and renewables. One more activity we conduct is organization of the conferences and workshops, and we have already organized 7 of them in Russia and 2 in Poland. And I invite you to take part, if you are interested in this issue, to take part in the next 6th international conference called Russia. It will be next in October 2022 in Moscow, and I'm going to continue this activity and upload the materials selected by the organizing committee in this database, in this system, in Russian and in English. So my conclusion will be that our university has many years of experience and a great potential to solve environmental problems and to study consequences of climate change. And our goal, so it's not only my vision, but the vision of the university is environmental preservation or environmental protection and limitation of the man-made impact from the industries. And system approach is the best way to solve the environmental problems and to train personnel, green-minded, I would say, personnel who can take environmentally responsible decisions. Thank you very much for your attention.
Yeah, thank you, Dr. Putilova, for letting us know the great work that you are doing. Is there any question to Dr. Putilova regarding environmental aspects, particularly related to electric mobility? Any question from the audience?
I can share my presentations. Sorry, I can share my presentation. There are contacts there in case you have any questions, any comments. I'm just open to your discussions. Yeah.
Yeah. So, so I'd like to ask you one question. That is, I don't know how it is being handled in Russia. This conference is actually focused on electric mobility, right? Mm-hmm. And just having an electric vehicle does not mean that there is no emission, right?
Yeah.
So only that the emission is actually happening elsewhere. It's not happening at the car.
Yeah. Yeah.
Yes. So and it's very much related to the nature of our generation. So both your country and my country has a significant amount of coal power generation. So we are actually emitting carbon dioxide, a good amount, when an electric vehicle is running. So I'd like to know, here's my question as to how, is there any action that is being taken to, have clean coal technology in Russia?
Concerning green coal technology, the first one is using coal ash in order as a raw material for cement and concrete production. Yeah. This way we just save CO2 emissions when we use coal combustion byproducts. It's one of the indirect way, I would say. And my idea is to have coal-fired power plants with no landfills, in order to process the maximum value, the maximum amount of the coal ash produced. But in this way, we have to fulfill the requirements of the customers, and we have to analyze the market, what is needed. Yeah, and there should be the roadmaps, the strategies concerning this issue to be developed. Yeah. And if we are talking about coal-fired power plants, yeah, we are not going to stop coal-fired power plants in Russia because, Siberia, the Far East, and the Urals, we have coal-fired power plants there, and what to do. It does not mean that we are not going to implement new technologies, but in case we are thinking about the carbon capture and storage, we need to think about the efficiency of power plant, yeah, because it's like a balance. If you install the investment, the first point, the second one is the efficiency of the power plant as a whole. So it should be calculated in every case, I think. What is the best? It's according to the national plans, it's according to the regional plans and so on. Of course, we need not to dispose of the unwanted, unused part. We need to think about the circular economy, of course. But first of all, we don't need to just dip inside and not to calculate, just take the new experience and try to use it. It's my opinion. I'm sorry, maybe you are not.
Yeah, no, that's fine. That's fine. Thank you, ma'am. So, ladies and gentlemen, we come to the end of a very exciting session, and I would like to announce a 10 minutes break for the audience, and then the next session will begin.
Professor, there is one question from one professor. Please look at it.
There's a question.
He was raising the hand now.
I'm sorry, I didn't. It's okay. Let me have a look. Somebody raised hand. Is it?
Please go ahead. Maybe
Yes.
he is not interested.
Yes, sir. If anybody has a question, yeah, I didn't see anything in the chat box, and I think that person may have left. Yeah. So I think there is no problem. We can end this session, and please come back after about 10 minutes. Thank you. Thanks, everyone. This session is closed.
Thank you very much.
So welcome back to this last session. This session is going to be chaired by Professor K.V.K. Rao, Professor in Civil Engineering at IIT Bombay. So I request Professor Rao to take over.
Okay, so am I audible, Professor Agarwal?
Yes, you are. Yes, you are.
Okay. Thank you. So welcome you all to this last session, was along with the concluding part of this conference, wonderful conference. So welcome you back to this last session of this conference. So we have two very interesting presentations lined up and followed by a discussion. We can discuss about all the aspects that we have talked about in this conference towards the end. So the first presenter is Professor Fernando Castro Pinto. So he's from Mechanical Engineering Department of Federal University of Rio de Janeiro, Brazil. He actually works, also read out his areas of research. He works in the areas of noise pollution, signal processing, machine design, dynamics and control of mechanical systems. So he would be talking on challenges of the electromobility in large countries. So with those few words of introduction, now I request Professor Fernando Castro Pinto to go ahead with his presentation. Professor Pinto. As he Professor Pinto, are you there? We are able to hear him. I am unable to hear. No, we can't hear him, no? We can't hear you, Professor Pinto.
Yeah, there is a problem. Yeah, we can't hear.
Yeah. Send in. We can't hear him. Professor Pinto, can you hear me? No, we can't hear you. I think it appears none of us can. Yeah, now it's okay. Yeah, please go ahead. But please share your presentation.
Can you see the presentation and hear me right now?
Yeah, very clear. Yeah, please go ahead.
Yeah. I'm sorry, I think when I started the sharing of the screen, the microphone configured in another way. Well, once again, thank you very much, Professor Rao, for the kindly introduction as before. I will be having this talk about the challenges of the electromobility in large countries is not intended to be, let's say, solution posing talk, but rather bringing up topics that we should be aware when we try to speak about electromobility, especially when we compare the situation from, let's say, small countries and developed countries in Europe and large countries like Brazil, like India, like China, Russia, even South Africa, which are in a quite different situation. And sometimes our stakeholders, especially in the politics, must have a broader look than trying to import technologies or thinking, or even thinking. I think electromobility is the future. I think there's no way of stopping it. There's no way, and there's no sense in turning it back. But it must be seen as it is, not as a wishful thinking. But first, let me talk a little bit about the Federal University in Rio de Janeiro. It is the oldest school of engineering in the Americas. It's the first school of engineering in Brazil, of course, which then gave rise to the Federal University, joining all the faculties together in the course of the years. Now it's one of the largest federal universities, located, of course, in Rio de Janeiro. Is run by the federal government. It's a public institution. We have about 70,000 students in undergraduate and postgraduate courses. We have about 200 courses, undergraduate courses, about 200 postgraduate courses in almost all fields of the knowledge, especially in engineering. We have a strong presence in Brazil. We have courses in all fields of engineering. We develop research in all fields of engineering. But of course, the university is closely related to Petrobras, the oil industry, which is, well, at one side, a pretty good thing because we have access to research fundings from them. But on the other way around, we must, let's say, diverse our interests, especially in this moment where the automotive industry is facing this challenges of changing its main technology, going from the internal combustion engines and maybe going up to autonomous driving and such things that are happening in a very short time lapse. Well, we at the Federal University are trying to cope with this. We are developing some projects, some research and development projects. I will talk a little bit about them at the end. I think you've already heard the presentation from Professor Richard Stephan about the magnetic levitation train. Is another direction we are seeking, especially related to urban traffic. Well, as you can see, we talk about sustainability and mobility. Well, sustainability is not to be debated. It's necessary, and present mobility of, especially in the cities, is not well posed in this way. We are burning a lot of fossil fuels, and noise pollution and air pollution, especially in big cities, is not to be tolerable anymore. But how can we tackle this? In fact, I will talk about this issue thinking about a large country like Brazil. I will talk much about the Brazilian situation and try to show you how this situation poses us a lot of challenges, a lot of things that must be discussed, that must be researched, and issues that must be solved before we think about, let's say, electrifying all Brazilian mobility, especially all Brazilian vehicle mobility. We strongly rely on individual mobility. The public transportation system in Brazil is not that developed, even in large cities, even in important cities. We really rely on cars, motorcycles, let's say internal combustion engines. But on the other way around, biofuels are increasingly important in Brazil. That means we are using more and more biodiesel, and some, let's say, over a decade, over, let's say, since the 80s on the last century, we are using ethanol as fuel. In the late 80s and 90s, the last decades of the 20th century, almost 90% of new vehicles in Brazil were powered by ethanol. The situation changed. We now have a mix of ethanol and petrol, but in fact, our gasoline has a content of about 25 to 27% of ethanol on it. And most of our cars can run on every mix of them. It can run directly on gasoline can run directly with ethanol, or every mixture of them. In fact, when running gasoline, it is running on 27% mixture of it. The public transportation mainly related to buses and vans with internal combustion engines, mainly running diesel. Biodiesel is not that widespread yet, but it's increasing, being increasingly important. And let's say train-like systems like subway or trains are a mode of transport in the urban cities, but it's not that widespread like in Europe. Other thing to be thought about is the transportation of goods, not only people, as we really rely on trucks. Trains is not that widespread in Brazil, although we have a large area to cover. But the transportation in Brazil, the infrastructure was built, let's say, in the 60s and 70s from the last century, and was heavily relying on highways, roads, on cars. In the first moment, it's cheaper to implement it. Well, and we should then try to change these these internal combustion engines by electric motors, but then how do we get there? Many people think that we will wake up next week and all of the engines will be changed to electro engines and everything will be green and nice and the environment will be saved, but we must have a close look at this. And of course, electric motors and induction motors, DC motors, is not a very difficult question. They are already established. They are running most of our machines, our industrial machines, and small devices and so on. So, of course, there are some issues to develop, especially when we want to use them in the in a car, in a vehicle, but it's not that big problem. Energy storage in the vehicle, like batteries, hydrogen tanks, or other possibilities, are still an issue, especially when related to range, to the autonomy of the vehicles, which is very important in large countries. And the energy flow control, like inverters and DC-DC converters for the various levels of electric tension that must be coped with. Of course, the energy storage outside the vehicle is a necessary issue to be tackled with, especially in the case of hydrogen. For Brazil, we really have a quite green energy matrix for the whole country, with a with intense use of hydroelectric power. However, if we should change all of our, let's say, fossil fuels by the electric energy, we must rethink our hydroelectric power plants, if they will be able to supply this, and if we then must change, let's say, thermal power plants or stuff like that, which would not be that green anymore. And is the network prepared? Not only talking about quite small issues like standardization. If I have to plug in my car in some outlet, how should I do this? What are the standards available? What are the standards being used? And we'll see that really very few stations in Brazil right now. And also the distribution network to feed all of these vehicles. And what if the country is large? Here, a picture of Brazil. Big amount of South America is only Brazil. If we take here from north to south or east to west, we have about 4,000 kilometers. Whole Europe can be put into Brazil. But of course, there's a large area of rainforest. I think you can follow my mouse here in the presentation. We have here this rural region here in the north. It's mainly rainforest. Well, not many people live in there. There are not many roads, but we must, of course, integrate these people in the country and in the country infrastructure. And we also have large areas of agriculture, especially in this region here we call the center west of the country, this whole region, but not only this region. Actually, it started from the south, growing up to the center west and stopping at the border of the rainforest. Is a very large area with agriculture, and we must have a flow of these products from agriculture into the big centers and into the export ports, mainly in the southeast and at the shore. Other issue is the distance between major cities. I will talk about this shortly, but the differences in development and for infrastructure in large extensions of the country. Of course, if we talk about Rio de Janeiro or São Paulo, we are quite well developed. We have quite nice infrastructure, but it's not the reality of the whole country. If we take here from Rio de Janeiro to São Paulo, the second largest to the first largest city, we must travel for over 400 kilometers. From Rio to Belo Horizonte here in Minas Gerais, from the second to the third major city, another 400 kilometers. From Rio to our capital in Brasilia, we also have about over 1,000 kilometers. And from Rio de Janeiro to Fortaleza in the northeast, over 2,500 kilometers. They are large distance. How can we travel this with an electric-driven car, electric-driven truck? How can we transport goods in this big directions? Of course, trains would be an alternative, a very nice alternative, but the infrastructure is not there, at least yet. Another point is that this region here with the agriculture has a poor infrastructure in terms of electrification and also in terms of roads. We can see this here very nice. These are pictures from the, let's say, nicest roads in Brazil. We have here a very nice road here to be ridden by motorcycle. I'm a motorcyclist, but it's very exciting and very nice. We have here in Rio de Janeiro nice roads around the shore, and in the center of the country we can see here a lot of trucks. These trucks are very important for the transport of these agricultural goods, and we can see here the status of the road. This is a road from Cuiabá to Santarém. If we can see here in the map, is more or less from this point here to this point here, from Mato Grosso to Pará. They are two important cities. Cuiabá is the state capital. Santarém is the second major city in Pará, and it's a very important center in the state. And how can our electric trucks, electric cars, autonomous vehicles deal with this kind of situation? We are not talking about having all of the roads like that, all of the roads with a nice infrastructure. So here we have about, let's say, 76,000 kilometers in roads. From then the paved roads, 65, a bit over 65,000 kilometers, but these paved roads are not all of them in really good conditions. That's the status of our infrastructure. Of course, once again, in the southeast or in the south, where we have these nice pictures here, this area is, let's say, well served in the infrastructure. Northeast, we can also think that in the at least in the shore we have good service here, but inside the countryside is not that well that good. And the same happens with the electrification. If we see here only the major transmission lines, we can see that in the southeast we have a lot of lines here from Itaipu to the centers in Rio and São Paulo. It's our very large hydroelectric power plant. But again, well, in all this area here, in the whole area here from the north, in this rainforest, and much of the center west, we have isolated systems running on diesel or other fuels. In fact, we have from over almost 60% is from hydroelectric plants, only 25% from thermoelectric plants, mainly running on natural gas, and little bit in diesel, small amount of nuclear, and small 10% of solar energy. It's not that much. 3% are small hydroelectric center power plants. So we quite green in our electricity generation, but this is not intended to support the transition for the electromobility. Of course, if we compare Norway, and I will use Norway here only because in Brazil it's widespread that in Norway, let's say almost 90% of the new vehicles are electric vehicles, and that's a big thing. Of course, Norway is quite small in comparison to Brazil. Even if you think from Oslo to Trondheim or Bergen, we also have, let's say, 400 kilometers, but the nature of the roads puts up a very large amount of time for this travel and a lot of stops due to the climate, due to the mountains and so on. And the research and development decisions are quite based on Europe, let's say for the automotive industry, and at least in Brazil, are taken by people sitting in Europe and taking a look at their reality. And the question is, will these decisions, will these developments be, let's say, interesting for us? If we take here our circulating vehicles, and 2019 about 60 million, 2020 is about 60 million if we count on the motorcycles, about 48 million vehicles without the motorcycles. Well, if we take an average of 15,000 kilometers a year, that's our average here in Brazil. Okay, we may reduce this to 10,000 kilometers, and we can calculate the amount of energy necessary to run this vehicle. And we also can see here that Rio de Janeiro, São Paulo 30% of this fleet, Rio de Janeiro and Minas Gerais, these are the three, let's say, most developed states, the most the big largest economy in the country, and also the south. We have the fleet concentrated here, but we must take goods from here, from the agricultural centers in Center West to these cities, and we have to transport industrial goods on the other way around, and also on this big region here. This whole region, here we have rainforest, but this region here is responsible for food, for agriculture, and that's the main issue. Here, our consumption in, let's say, fossil fuels, we have in the years an increasing percentage of vehicles running on, let's say, three fuels: gasoline, ethanol, and also natural gas. Diesel is mainly for trucks and for good transports, buses and so on. And well, gasoline only is diminishing, but many of these vehicles are not running only in ethanol, but on this mixture that is related to cost factors. And if we take a look on the licensed electric vehicles right now, we have about, let's say, 11,000. If we add up all this year, we will have, let's say, 20,000, or let's say 50,000 electric vehicles running in Brazil right now, and they must be compared with this 60 million vehicles.
Professor, sorry, Professor Pinto, can you hear me? I think, yeah, I'm afraid I think we are now very close to your finishing time. So maybe a couple of minutes.
I will try to finish.
Yeah, thank you.
And mainly of these vehicles are quite costly vehicles, and we have to tackle this challenge of the battery powered vehicles, mainly only for urban use. It's, let's say, for us, the hybrid vehicles will be an alternative. Fuel cell might be used for for public transportation, motorcycles in the cities for delivery service, but the long-range goods transport still challenges for the agribusiness, and costs must be lowered. So here is the amount of filling stations we have, and there is only 400 electric charging stations right now, but we also have to fuel vehicles. So how can we improve this, especially thinking about costs? Well, possibilities: hydrogen production from natural gas. We have plenty of natural gas, especially from the pre-salt reservoirs, but we have to deal with the complex storage and transportation. And solar and wind might be used for hydrolysis. In the Northeast, we are starting an interesting project on hydrogen generation. And in Rio, due to the abundance of natural gas, research and develop activities, we must bring this to the country and think on the better infrastructure for the distribution of this electricity, and is an autonomous vehicle thinkable in this situation. So the long transport is still an issue, and it poses a lot of challenges. We are running on small 8.2 powered vehicles, an experimental platform, small 8 passengers minivan, to be used as platform for assisted and autonomous driving research, a small motorcycle for urban delivery. We are running these projects right now in the Federal University of Rio de Janeiro. We are also having some partnership with the industry, which is now developing these trucks. These trucks are battery-powered trucks, electric trucks to be used in urban delivery. We have a competence center which were funded by the CEE, especially with engineering, trying to improve the engineering courses related to the electro mobility and for these challenges of the electromobility in a lot of these areas. We also have the possibility of a very small urban test circuit in our technology park, which is open for this research. Less also smart traffic management, biofuels, of course, is also another research field from us. Electromobility is the future. There's a lot of issues still open that must be tackled, but the characteristics of these large countries like Brazil, like India, like China, like Russia, and also like South Africa, with this mix of poorly infrastructured areas and well-developed areas, and this must be taken into account when we think about having the electromobility as a major factor in our countries. I think that's a point that we must see as challenges and opportunities, but we must think about this in let's say quite rational way. Thank you very much for the nice congress, and thank you very much for the opportunity.
Thank you. Thank you very much, Professor Pinto, for very elaborately and very informatively bringing out all the challenges that a large country like Brazil and India and all other large countries have to cope with when they want to move in a significant way towards e-mobility. So I'm sure that there will be some interesting questions that may appear. You can also raise your hand, not only in the chat box. If you send any message on chat, I will be reading out. So we have a couple of minutes for this discussion. Don't see anyone. Okay, so yeah, I think maybe. So are there any queries, quick queries, any quick question? Okay, so in that case, I think we'll move on to the next presentation. So the next yeah, please. Yeah, who is this, please?
Yeah, this is Shashif.
Yeah, please go ahead. Yeah.
Yeah, what is the biodiesel future? It is started for a long time, but what is the future and what are the advantages? Means not advantage, what are the advance is going on this direction?
If I understood well, you are asking about the future of the biodiesel, the biofuel.
Yes.
Brazil has a large fleet of trucks, and our good transportations rely heavily on trucks. That's why I don't think that in the, let's say, near future, we'll be able to change all of these trucks to electro vehicles or similar solutions. You can see the roads in the countryside are not well suited, and I'm showing here some problems with mud, but we also have problems with floods, and having all this electricity in this environment, it's not that easy to solve in, let's say, a few years. So the use of biodiesel is increasing in Brazil. We have different ways of generating them due to our agriculture diversity, and Petrobras is still heavily investing in biofuel. We have a dedicated laboratory for this. We have very important research fields in biofuel development. And it's the diesel in Brazil has some biodiesel in it, but it's not in a large amount like in gasoline, where we have 27% of ethanol. And ethanol, as another biofuel, is very important for Brazil, but I think in the present we have some cost issues with it, and costs due to this transportation from the agriculture where it is produced to the let's say for the centers where they are used in the southeast. But I think it's still a point that will be going on for the next years.
Thank you.
Okay. Yeah. Okay. So yeah, thank you, Professor Pinto, and thank you, Professor
Thank you very
Mitra, for
much.
that very interesting question. So we'll move on to the next presentation. So the next presentation is by Professor Dmitry Shashif. So he is associate professor at Tomsk State University, Faculty of Innovative Technologies, Russia. His areas of research are image processing and recognition, machine learning, autonomous vehicles, and robotics.
Greetings, dear colleagues. Do you hear me?
Yeah, I can hear you. Yeah, please go ahead.
Okay, great.
Yeah, please share your presentation, maybe.
Let me a second, please.
I hope you would be able to finish your talk within 20 minutes.
I'm trying.
Thank you.
Okay, thank you very much. Do you hear the presentation? Tell me.
Yes,
please.
yes.
Okay, great. Let's begin. Once again, greetings, dear colleagues. First of all, thank you for coming here today and providing us with a platform in Brics. It's an honor to be presenting in League with the best and brightest minds. I will be speaking about e-mobility in drones, actually about our experience and our developing. But before I start, let me tell you a bit about us, who we are, and so on. Just I'm representing the National Research Tom State University. You can see our main building and our winter on the slide. And we are one of the best universities in Russia today. We currently host about 15,000 students, with 3,000 of them coming from various foreign countries. We are actively eager to welcome everyone with an open heart and a quest for knowledge. Actually, we have huge variety of study directions, including microbiology, linguistics, radio physics, and much more. About me, my name is once again Dmitry Shashif. I'm a professor at the Faculty of Information Technology. And actually, our mission is to help students reach their best capacities and encourage our students to actively take part in research projects for the betterment of the scientific sphere. And here you can see our main direction. It is applied in robotics, quality management, and innovation management. And you can see our environment with our students and robotics, actually. Okay. We have multiple projects with mobile robots from our lab. For better understanding the name of lab, the Cyber Physical Systems Lab, and as for our motivation, I truly believe that mobile robots are the future of automation, and actually the future of mobility is in the drones field, I guess. Okay, moving on. The first project I will talk about is the all-terrain robot. It had the payload capacity of approximately 10 kilojoules and can reach speeds of up to 60 kilometers per hour. It can climb up stairs, walls, and can navigate roof or watery terrain. Moreover, since we are based out of Siberia, we can confidently say that this robot and all our projects can withstand the harsh and snowy conditions of Siberia. This robot can be used for, as you see, exploration work, for the rescue of drowning people, for the conducting engineering, radiation, reconnaissance, and so on. The next highlighted project we have was very useful during the COVID pandemic. During the lockdown, we have assisted in delivery of medicines and other necessary supplies to affected hotspots to minimize contact. Moving on to the next project. And one of our big projects and one of our currently ways in research is the Drone Hunter project. It is an all-round aerial and land defense mobile robot, which has been funded by the Ministry of Science, by our Russian ministry. It has two main units, the unmanned ground vehicles, or the tank you can see below the drone, which is used for land surveillance and defense, and the UAV, or the hexacopter, are used as its aerial counterparts. The ground platform is equipped with a cellular network jammer and multiple other sensors. You can use actually this type of robots independently of UAV for example, land defense and radiological, biological, and so on. Okay, let's move. And this is like an advertisement of our products. Actually, I hope you see the video. Our robots in actions, actually. It spends not so much time. Just I want to show you how it works, that it's a really good project. Actually, it is also e-mobility, I guess. Okay, and some words about drone system architecture, because it is more important today. And for us, it is about hexacopter, is all-round aerial defense platform, which is designed to detect, eliminate, and capture threats. It's deep integration of the onboard sensors, as you see on the slide, LiDAR, Z-stereo camera, ultrasonic sensor, with the computing platform, as you see in video, Jetson Xavier, for example, helps it to detect and read in real time. It can also capture and retrieve threats if required. It can also signal the ground platform with GPS coordinates in cases of emergency. Moving on. And you can see, I hope you can see the Drone Hunter in action, how we catch the drones and how we recognize it on board. Okay, moving on. Just one of our also project related to small cargo drone. As you see also the video. This project have done with our partner, industrial partner, Geoscan. And just like additional information, I'm happy to invite you to our masterclass, Programmable Drones. If you're interested in it, you can contact me, for example, or as I know, you have a contact of our vice rector. You can also contact him. Actually, we are free for collaborations in academic sphere. For example, we have the master's program Applied AI and Robotics, and we are ready to work with you, with your universities. Thank you for your attention. Thank you.
Thank you, Professor Shashif, for that very interesting presentation, especially relating to various kinds of drones that you and your university has, your research institution has developed. Quite interesting. So now the floor is thrown open for discussion. So are there any queries to Professor Shashif? Yeah, you can send on chat box, as well as you can also raise your hand. You can unmute yourself or directly ask the question.
Maybe it's better to write in chat because I have a bad connection, unfortunately, and it will be helpful for me to understand correctly the question.
Sure. Yeah. Yeah, can you please write your question in the chat box? Okay. Professor Shashif, I have one question. Can you hear me?
I hear you.
Yeah. So are there any, these drone technology that you have developed, have they been used by any industry for mass usage?
No, not some part, yes, but not whole of this, because mostly it is research and development. But we have some projects with our industrial partners that we are going to use in mass, in commercial sphere, but not all of them.
Okay. So how about your cargo drone? Maybe people are now talking about them being used extensively by e-commerce. What is the status maybe in Russia in that count?
I guess I can say that we are in the beginning of our way, because actually market is not ready for this technology, at least in Russia right now. We are trying to do it, and our big industrial partners like Geoscan, as I showed you, try to experiment in this field, but we are in the beginning.
Okay, so what about the development of maybe electric VTOL, I mean for passenger transport, vertical takeoff landing aeroplanes? Is there anything
Just
going on?
in Russia, some research team do it actually, but in TSU, we right now focus on the drones only and fixed wing aircraft. I mean, just it is not about the passengers, passenger vehicles.
Okay, so yeah, thank you for answering all those questions, and interesting talk as well. Looks like
Thank you very much.
No other questions I see. So then we'll move on to the next presentation.
Everything was good.
Okay, so yeah, so we'll move on to the last presentation of this session. So the last presentation is by Professor Sandeep Anand from Department of Electrical Engineering, IIT Bombay. So Professor Sandeep Anand works in the areas of DC, AC and DC-DC conversion, reliability of power electronic circuits, gallium nitride based power converters, circuits for interfacing renewable sources. So he will be talking on power drivetrain, glimpse of research at IIT Bombay. So Professor Sandeep Anand, please.
Yeah, thank you, Professor Rao. I hope I'm visible and audible.
Yeah, you are definitely audible. Yeah, now you are visible. Yes, thank you.
Okay, and my slides are also there, right?
Yeah. Please go ahead.
Yeah, thank you. So, yeah, I would, talk about power drivetrain, and I'll talk about this subject in a multidisciplinary fashion. Would try to incorporate the work being carried out by not only me but some of my colleagues at IIT Bombay. Yeah, so this is, the first image we get in general when at least I think about internal combustion engines, right, conventional vehicles. The left image shows us that there is a lot of parts, right, lot of components, and which is a very well-known phenomena. So the conventional vehicle is actually, so in a way it's so magical. So many parts sort of, put together, combined, work in harmony, and sort of make these vehicles. But now people have started looking at it as as one of the challenge which the EV counterpart solves by reducing the number of component count. The second image is of the tailpipe emission, right? So I think yesterday's talk, Professor Rao did talk about, that if the EVs are still powered by conventional coal-based electricity, so it would still be polluting, yes. But at the same time, the conventional vehicle sort of, directly pollutes at the point of load, which is what is shown here. And the third is the import. So I think Honorable Minister Shri Nitin Gadkari also mentioned that import of some of these fossil fuels is certainly one of the important issue for any country, and therefore minimizing it is definitely an advantage. So if we talk about more and more renewable deployment, and then using vehicles which can use that electricity would put together would also help solve or alleviate this problem. So EV as such looks a bit simpler, especially in this diagram, because I've only drawn a few blocks. It charges the battery. There's a power converter which takes the power and drives the motor, and then there are mechanical systems which take power to the wheel. So the advantages, as I mentioned, zero tailpipe emission, centralized energy conversion from fossil to electricity might be more economical, more efficient. Distributed renewable-based generation could be used to power these EVs, which could be green, and low component count. So this is the general power drivetrain that is there. Or these are the different segment which sort of constitutes the power drivetrain of an EV. Starting from the DC power, you have an inverter followed by a motor, which further feeds mechanical energy to the wheel. And in the process, all of these three elements sort of dissipate heat, which goes out as a thermal waste energy. So, my presentation would actually talk about all these, three or rather four main subsystems of EV drivetrain. First is the power converter, which constitutes both the devices which go into that, as well as the system level, which is the power converter itself. Then the motor, right? What about the motor design, fabrication? And third is the how do you manage heat, which gets dissipated from all of these subsystems in a vehicle. Before I go ahead, just a quick note is the cost versus range trade-off, right? So usually, if a vehicle needs to have a larger range, you can pack in more battery, you can make it more expensive, right? And yes, it will have eventually higher range. So the range anxiety is sort of cost and range anxiety, not only range anxiety. Now, how these subsystems play a role in this trade-off? So for instance, if we can make all of these subsystems much more power dense, that means we can make them smaller, lighter, then with the same battery capacity, the vehicle will have a lighter weight and it can run for more kilometers, right, or more miles. So a higher power density would actually reduce the cost or increase the range. Similarly, if these subsystems again are very efficient and the power loss happening in the converter and the other subsystems is minimal, then again same battery pack could give larger range. So that is the second quality of the subsystem that we are looking for. And the third is the reliability. The IC engines has been on road from decades and they have proven their reliability by now. These vehicles are relatively new. They are based on completely different architecture, different technology. So how about the reliability, the long-term reliability of such systems? So these are the three important qualities that these subsystems should have, which is high power density, high efficiency, and high reliability. With that, let me touch upon each of these subsystems one by one. So I'll start with motors. If you see motors, these are the two key features. I spoke about power density and efficiency, right? In terms of power density, there are three types of motors primarily. One is hub mounted, which is essentially mounted in the spoke of the wheel. Second is the medium speed motors, which are certainly coupled through a gear of, let's say, a gear ratio of 1:5 or something like that. And third is a little bit futuristic, where we have a very high speed machine coupled to the vehicle. As we move from top to bottom, we understand that as the speed increases, the size of the motor would come down. But then they may not be suitable for all the varied applications. For instance, the high-speed one is probably going to be an expensive solution because of the specialized bearings and other things. A hub motor, on the other hand, could really help in reducing the losses that are happening in the gears, right? Because it directly gets mounted on the wheel, it does not have to take care of that. So among the three, although power density wise, yes, the bottom one would be the best, but then each of them have its own advantage depending on which application of EV we want. Similarly, efficiency, right? Now this is NDFEB magnet-based, permanent magnet-based motors. We can have ferrite-based motors or magnetless motors. Again, the top would have the highest efficiency, but at the same time could be the most expensive one, right? Because this is based on one of the rare earth material. Again, so depending on the application, there could be trade-off among these three. So in general, the philosophy is that the same motor may not really fit all the applications. For instance, some of them may be easily repairable, maintainable. Some of them may require more sophisticated instruments for them to be maintained. So if you're talking about rural application, maybe a machine which can be easily repaired would be preferred. Road condition, there was an interesting talk yesterday on road conditions, and therefore, again, if you're talking about rural areas, the road may be bumpy and you require a motor which is more rugged than a more sophisticated high-performance motor. Hilly terrain, there could be different use cases for rural and urban. So with that philosophy, some of our colleagues from the department have been working on different types of machines. For example, the top, what I've shown is more of a conventional brushless DC motor for e-auto rickshaws for about 4 kilowatt. Here, this is meant for e-auto rickshaws, which are to be sort of driven in metros where there are steep slope, so you need higher power to go up and then come down. On the left side, I show another work, which is in fact a magnetless motor, which is a switch reluctance motor. It's a hub type of motor, and you can see it's being mounted on this cycle for testing purpose. The same concept is being very popularly also employed for scooters and so on. So this is, again, another extreme of the application, and something in between, which is a ferrite permanent magnet assist synchronous reluctance motor, which is a really sort of trade-off between these two. Not as expensive as VLDC, does not depend on the ND-FEB magnets, and at the same time has better performance and higher efficiency than the magnetless versions. So these are, some of the, this is the rotor which is shown. These are the magnets which eventually gets pasted on these things. So this was one part of the motor. The second is now, I think there was interesting talk on hybrid EVs. I remember Professor Mukhopadhyay from IIT Kharagpur gave that. So as auto industry is sort of evolving, I can share it for India. BS3 phase 2 norms are about to come. So BS6 phase 3 happened, I think, last year, 2020, and another couple of years we'll have a new set of norms. And now these new sort of norms are even more stringent on the pollution levels and so on. And now what is being visioned is that soon most of these vehicles would have to eventually turn to hybrid vehicles to meet those stringent pollution requirements. So one of the statement I quote from this article is meeting the new requirements will obviously require us to have alternate powertrains, whether it is electric vehicles or hybrids or something else. But it is very clear that simply the IC engine will not be enough to meet the new requirements of 2022. This is by Dr. Pawan Goenka, who was the former MD and CEO of Mahindra & Mahindra, which is one of the automobile manufacturer, one of the largest automobile manufacturer. So we did a work collaborating with one of the company and where this was a hybrid motor which would actually assist the main engine and make it much more efficient. And this is the controller that we designed for it. In terms of the facilities in motor, we have we have design software, we have the testing facility and part of the in-house fabrication. This is a video showing one of the PhD students validating her own machine design on the facilities that we have. Next comes from motor, let's go to the power converters. I will sort of quickly give you a recap or revise you that we were talking about high power density, high efficiency, and reliability. So now how do we achieve these three aspects in a power converter is by utilizing something called as wide bandgap devices. So gallium nitride, silicon carbide are the popular wide bandgap devices. If we use these because they can withstand higher fields, these devices can be thinner and smaller, and which reduces their on-state resistance and which eventually reduces the losses. So if the losses reduces, you get better efficiency, right? You need smaller heat dissipation components and therefore again higher power density. So both the first and the second objectives actually get met if we move for these devices. With that motivation, let me show you. So if you see the right-hand side figure, that shows not just the main converter, but there are so many other subsystems, sub-converters in the vehicle, right, which requires these power electronic circuits, and all of them has to use power devices, and wide bandgap power devices is one solution for EV. On the bottom, I am showing some of the nano fabrication facilities that we have at IIT Bombay. Next is some of the research carried out by our colleagues from the institute. So you see that left side is the growth of the gallium nitride over aluminum oxide. The next figure is the design for a gallium nitride based power device. This is an actual picture of a fabricated gallium nitride device in our facilities. In the bottom left, it is the silicon carbide based device design, right? On the bottom right, it's gallium oxide based in-house fabrication, where the left side is the design, and rightmost shows the actual performance of the fabricated device of gallium oxide. So this sort of sums up that there is a device fabrication that and in device research that we are doing. Now, once the power device is there, how do we put it into a converter and make the actual system, which is I've tried to capture in this particular slide. So if you see left picture is actually a DC to DC converter. I showed you just some time before, there are so many components, so many subsystems which require these power converters. This is one of those. And what we have done is we have utilized the gallium nitride devices in this particular converter, and with more innovation on the circuit side, we could do soft switching and improve the efficiency. The right top figure shows another subsystem where we have demonstrated very high power density of the converter. The bottom right figure actually shows how the power density has evolved in some of the research I've been carrying on, going from 5 watt per inch cube to about 25 watt per inch cube. So then another good application that our colleagues have been working on are integrating supercapacitors, ultracapacitors in the electric vehicle. So this picture actually shows you that, this along with the top one. The right bottom is the silicon carbide based inverter stack, which could be used for, let's say, car motor drive applications and so on. Okay, now this is, I spoke to you about reliability of these power converters, right? Because they are being used for the first time in such harsh environment, how would they respond and so on. So quite a lot of research going on in this area as well. The left video actually shows you a capacitor which was accidentally aged, and therefore, it just gives up at one point of time. And by doing multiple of these studies, we can evaluate the lifetime prediction of some of these subsystems or subcomponents that eventually goes into the electric vehicle. So quite a lot of monitoring and accelerated aging of the capacitor and the other devices. Okay, coming to the last part of my talk is the thermal management of EV. Now, this is the part which is which is done by our colleagues from the mechanical engineering department. So if you see conventional IC engines, right, the cooling requirement was mostly focusing on the main engine, which could actually tolerate reasonably high temperatures. But now when we are shifting to these power electronics-based vehicles, electric vehicles, the temperature requirement is now changing. For instance, the motor can still take or sort of accept higher temperatures, followed by power converters, and batteries has to be sort of regulated at a much lower temperature. So now the challenge is, earlier there was one main guy dissipating heat, but now there are these 3 subsystems dissipating heat, and plus they need to be maintained at different temperatures. So a lot of interesting research colleagues are working on these things. One of them is pumpless cooling system for EV. So essentially, there is no pump which sort of circulates the liquid, and by doing that, they could improve the overall reliability of the subsystem by eliminating the pump. More so, they experimented with different fluid instead of using water, and they could show much more consistent temperature in some of the other fluid for different heat flux values as compared to water. This part they have been working on with Cummins and sort of could find application for EV, even for high power vehicles and so on. Next is cooling of battery. Right now, the air-cooled systems usually would be able to cool battery, but then depending on which cell is on the outer surface, will get cooled better, and the one on the inside may not get cooled. And you see that if it's a natural convection, the cell temperatures are quite varying. But then if it's an immersion-based cooling where you immerse it into a mineral oil, something similar to what electrical engineers do for transformers winding, let's say, then the overall temperature of all the cells can be maintained uniform. So there's been experiments and validations going on in this area. The last slide I have for today is this one. Again, a very interesting sort of example of how things change when we move to EV is that the fan which used to be there in the front of our cars could never bother us with its sound. But if you talk about EV now, because the engine is gone, that fan sound is the most significant, and especially its frequency is something which may not necessarily be very acceptable to users. So a interesting research a colleague has been doing on is how do you minimize the sound coming from that fan, at the same time improve the cooling performance. So this is a hybrid heat sink which acts as a heat sink as well as absorbs the sound coming out of it. So these are some optimizations done so as to improve the design of this particular subsystem. Thank you. I hope I could convey some of the interesting research going on in this particular area at IIT Bombay. I've listed down some of these areas, the 4 areas which I covered, along with the names of a few of our colleagues. Obviously, there are many colleagues and their students and their funding agency and everybody put together has been actively working on these areas. Feel free to reach out to them. If you have any comments for me or questions, please feel free to reach out to me. All of us would be very happy to explore possibilities of collaboration and strengthening in some of these areas. Thank you.
Thank you. Thank you, Professor Sandeep, for that very informative talk. I think you have made us know about what IIT Bombay is actually doing, especially relating to the core aspects of electric vehicles, relating to the power drive train. So thanks for that information. And yeah, Professor Amit Agarwal, I think I will hand over to you right now. I think all the presentations of this session are done. So maybe you can intervene now.
Yes, so there is a discussion section that you can coordinate and then you can.
Pardon?
There is a discussion.
Yeah. Okay. Yeah. So I think we have at least maybe minimum about 20 minutes, 15 to 20 minutes for the discussion on considering what we have done in these 3 days. So first, let me also a little bit summarize what we have done from my side. Yeah, I hope you can hear me. I hope. Okay, thank you. Yeah, so basically, I think this wonderful conference on the current hot topic of e-vehicles as actually can be summarized with those wonderful maybe presentation, all those wonderful presentations that happened on all 3 days into maybe 3 broad components. One is, of course, the sustainable transport and policies and modes. Considering this electric mobility and also the various kinds of technologies into maybe energy sources like even hybrid vehicles, then maglev systems, then also drones. So these are even vertical takeoff landing kind of electric planes. Then the core research on the charging infrastructure and batteries. And we also have some interesting, of course, explanations and case studies about what their respective institutes are doing at their own place. So in fact, this conference has actually started with a broad discussion or broad presentation on sustainable urban transportation. And there, of course, we learned we need to look at all the three components of sustainability. So the transportation systems have to be environmentally responsible, economically viable, and as well as socially acceptable. So all the three components we need to address. Now, when we look at these e-vehicles, of course, they will definitely contribute to a very great extent in reducing the emissions. But at the same time, a review of a lot of literature, it actually tells us that though the tailpipe emission is completely removed, but it is actually transferring the emissions at the production end. So unless we improve our electric generation, decarbonize our electric generation, so we may not be able to increase the benefits that we are going to get because of e-vehicles. Of course, the health and well-being of the people will definitely improve. And then we also need to look at the safety aspect. So towards that, I think in my presentation, I brought in the electric two-wheelers, where we need to what mode we need to give importance in converting them into electric-based vehicles. So in Indian context, definitely two-wheelers is one segment where we need to target. But at the same time, in order to reduce, improve the safety of those vehicles, we need to also think of making all kinds of measures like exclusive lane and special treatments at intersections for these e-two-wheelers and so on. So there are also presentations so relating to this broad policy, broad sustainable transportation. So there is an interesting talk from Mr. Victor from Aerospace Technologies about he suggested mobility as a service. But then there are questions about the equity aspect there. Professor Bino Paul has rightly brought out what is the impact of this e-mobility on a particular social segment. He talked about the self-employed people who need actually a lot of mobility, and how we can make these e-vehicles more equitable so that their needs are also satisfied. And Professor Stein from University of Pretoria has talked about the need of e-mobility, not only in urban areas, but also for long distance travel as well as rural transportation. He very aptly brought out the importance of integrating, looking at the requirements of especially the transport infrastructure like road network, and also the accessibility, how accessibility, connectivity and mobility in that order can be actually addressed by even moving towards e-mobility. But these basic things one should not forget when we are moving towards a new technology, which is going to definitely help us in reducing the emissions. And a similar view also has been given by Mr. Filho, President of the Brazilian Association of Electrical Vehicles. He broadly talked about the current policies of the Brazilian government and also the current very low penetration of EVs. So he actually feels that there is a lot of impetus that should be given by putting on some important policies. So then there is also a very good presentation by Johan Hubert from University of Pretoria. So he actually very well connected everything. So we have obviously a question about how we are going to evaluate the benefits of any system change that we actually incorporate. So he has presented the agent-based simulation model through which they will be able to actually examine how things are going to be. Even the questions of equity, the question of the kind of impacts that these EVs are going to bring in can be very well examined using these simulation-based, agent-based simulation models. And also similar views are expressed by Professor Pinto. He also narrated about the similar experience of their university, their research in Brazil. So his basically the point that Professor Pinto raised is how we can take care of the issues that come up when we want to implement EVs in basically large countries with very large transport networks, distances ranging even more than 4,000 kilometers. So of course, he talked about various issues of charging stations, infrastructure, and so on. So he also brought in the importance of the actual transport infrastructure to be ready in order to have these kind of technology changes in mobility. So of course, there are presentations specific to the implementations in the university campus. For example, Dr. Redina has presented the kind of things that they are doing in order to reduce the impacts of the transportation that is right now there in the university because of the external transport. And they are actually also thinking of how the pressure of this external transport links passing through their university can be reduced through a proper policy. One of the policies could be maybe e-vehicles, increasing the e-mobility on all those external transport links. And we also talked about various kinds of alternative transport technologies. So one of them, of course, is hybrid vehicles. A wonderful presentation has been delivered by Professor Mukhopadhyay of IIT Kharagpur. So one thing he also given a very nice table how in terms of emissions, the electric vehicles, hybrid vehicles, and the ICE conventional vehicles compare. So as of course, one important aspect that we can learn from it is once we have these hybrid vehicles, why not we also concentrate, do much research on these hybrid vehicles, because the charging happens within the vehicle. It may not be needing any kind of external outlet. So can we improve that component of charging, internal charging? And also the range anxiety can be is completely eliminated because of these hybrid vehicles. So there are certain advantages of hybrid vehicles. So maybe within the transition period also we may have to also look at these hybrid vehicles. Then we also have seen another different system, superconducting maglev system, which has been actually wonderfully presented by Professor Richard Stephen of Federal University of Rio de Janeiro. So it appears that their research is mainly for use in urban areas, though these kind of superconducting maglev systems are meant for very high speed intercity. But it is interesting to know that these actually can be used for urban transport commuting. And it appears that it has a capacity equivalent to any light rail system. So wherever there is a requirement, we can also think of, because these also mainly on electricity and they don't cause any kind of environmental issues. Noise reduction also happens. And of course, in the last session, we also heard presentation from Shashif, who concentrated on the development of various kinds of drones, how they can be used for various purposes. So it was quite interesting. And a lot of very core technology presentations relating to charging infrastructure and batteries. We have heard a very good presentation from Professor Lee from Hunan University, who talked about improving the efficiency of charging infrastructure and the vehicle to grid technologies, very nicely presented. Of course, our own Professor Sagar Mitra has made a wonderful presentation about his core research on battery materials and also the future of this research, where it is, in what kind of direction it is going to take, like lithium ion and lithium metal battery research has been wonderfully presented. So Dr. Vladimir Kindra from National Research University, Moscow, he has talked about hydrogen technologies. So especially he has told us how hydrogen technology can also be used in decarbonizing the electric power generation.
记着，媳妇儿，没有人是绝对的七八岁的。
Okay. Okay, so so we also have another presentation by Dr. Putilova about the kind of things that their university is doing related to environmental technology. And finally, of course, our own Professor Sandeep summarized what kind of research is happening, especially relating to the power drive train from various groups of IIT Bombay. And I also would like to connect this by saying that definitely we just not have to not concentrate only on e-two-wheelers, e-bikes or e-cars. There are also out there various other modes which we have discussed. For example, the maglev system, the hybrid vehicle, as well as in which segment this e-mobility can be implemented. Maybe to start with, one is we have talked about two-wheelers, that is a priority as far as India is concerned, and also the e-taxis can be targeted, and also the public transport buses, they need to be become e-vehicles, and more so, in order to achieve the sustainability in transportation, we need to also achieve this multimodalism. We need to find out what is the role of each of these modes. So as a transport planner, we always say that public transport is the solution, and all these modes should actually become complementary to those mass rapid public transport systems. If we have a metro system in a city, maybe all these E modes can actually become last mile, give a last mile connectivity to that public transport system. So we should not forget about looking at the bigger picture and then see where which kind of component fits in where in order to finally achieve our sustainability. And also the last point, our director has very rightly mentioned that there is a excellence in center of excellence of e-mobility in IIT Bombay. So that of course has to take into account the expertise of various other units like of course transport planners, urban planners, sociology, along with the core departments like mechanical, electrical, energy sciences department. So I'm sure that with all these components already available in IIT Bombay, that Center of Excellence of e-mobility will definitely flourish and do whatever is required to achieve the sustainable mobility ultimately. So I conclude with that, and then the floor is open for discussion. I'm sorry, I think I have taken a little bit more time. So now, yeah, so do you have any, I think we can have some good discussion. Maybe I think we are 6:33. We have another maybe 7-8 minutes for discussion.
Yeah, so may I say something? I'm Siddhartha from
Professor Mukhopadhyay, please go ahead. Please go ahead. Yeah.
Yeah. So I think the one of the things that because we are going to leave this conference, we had a beautiful conference where we came together. I think one of the things that we need to discuss is how do we keep in touch? Okay. What happens next? Do we meet somewhere? Do we do another program? Let us say with our students. Do we identify 2 or 3 major themes that we could pursue? I think this is a central question. Then we can keep on.
Yes. Thinking. Yeah, I fully agree with you. I think you brought a very valid, important point. So basically, I think we have just seen how I think wide this particular topic is. So obviously, as you rightly suggested, I think we need to break down into various components and then start interacting with whoever is specialized in those aspects. I think it's a wonderful session. I think we should do that. Of course, our Dean IR is listening.
Yeah. First of all, sir, I think we need to get all the contact addresses of all the people. Then we are in touch. Okay. So if that is circulated, that will be wonderful.
Okay.
So and then maybe so let's hear from others. What is their what are their thoughts about going forward? How do we maintain this little momentum that we have gained?
Yeah. So are there any queries? You can use chat box. You can also raise your hand. You can directly unmute and start talking.
This is Sandeep here. Can I go ahead?
Yeah, please, Sandeep. Yeah, please go ahead.
Yeah, I think I like the idea of a student conference or something. Again, I don't know the logistics, but such kind of things as a follow-up, maybe not necessarily hosted by the same institution, but if is there anything being planned, then maybe a student conference could be something in this area to look for.
Yeah, so Professor Sandeep, do you think that we need to keep it as e-mobility? Now we have seen that it actually has a very wide range of topics within it. So do you consider the idea of basically when you talked about the powertrain train, so obviously it will be a Greek and Latin for us because but whereas transport planners will talk about how a bigger thing, a broader view, how in their network and in order to achieve equity, in order to satisfy every section of the population, how do you manage things? So that's what we worry about.
Yeah. So I feel in fact it was nice because there were so many varied topics even within the e-mobility domain. So all of us, especially I learned a lot from a lot of other talks. So I think e-mobility is an area which is one at the same time includes a lot of other. So it could be good to continue on similar thematic also possible.
Yeah. Okay. Yeah. Thank you for that. Yeah. Good intervention. Yeah. Are there any other? Think Professor Sagar Mitra is there. You would like to say anything?
Yeah, I am there.
Yeah. So do you have anything? Yeah, please. Yeah.
Yeah, I have some different opinions. So
Yeah,
I
please.
believe so. Very specific topic. Always we say it's a very specific. Anywhere you go, always we are same domain. We talk each other. But this I like because I come to know several things which
Yes.
everybody should listen each other and then try to, because this is a common thing like electric maybe electric mobility. It's not only the powertrain, batteries. It's a social impacts. There will be like environmental issues are there, policy issues are there. If we are not talking to each other, I don't think it never comes to a solution.
Yeah,
So I
absolutely.
feel together we should think about some common thing, maybe restricted, but not like a very specific, let's say, motors or
Right.
maybe transport. I come to know there is a lot of things are there in transport management, and that also need to be optimized for any purpose. That's why I have my different opinion on this.
Yeah, absolutely. I think I am now tending to agree with your opinion. So because yeah, when I heard Professor Mukhopadhyay talking about hybrid, and when you are talking about, of course, you made it so simple. I understood what many things.
No, see, if I go to any battery conference, I talk about because I listen to what is happening and what we are doing. That's an exchange only between the batteries. But electric mobility is not only the batteries; it's everything. Even we need to see this is a new technology is going to come. Maybe 200 years or maybe 130 to 140 years after this thing is coming. So how people will take it, how people feel it, even the social part also very important. Even Bino Paul is talking about so many things which is very interesting. Even if you think that directions, maybe this type of technology is not required sometime. So
No, I
that
agree.
is also one angle of thinking. So we technologies always think our own very narrow domain.
Yeah, absolutely. That's why we say sustainability is very important. The social angle of it. So
Even
if there is no
policy
social acceptance, yeah, our research has not much of impact actually, meaning also. So that way I agree fully with you. I think we need to do all the relevant topics so that everyone understands.
Yeah, we should
and
listen
then
each
connect.
other. Maybe we will not understand, but we should listen each other and then synchronize.
Yeah, absolutely. Yeah.
That
Okay.
much.
Thank you.
Yeah,
Professor
sir, can I say just one word? Yeah. So we need to hear from our colleagues from the other nations.
Yes.
So I see Professor Richard Stephen here.
Yeah.
So maybe we can request his view.
Yes. Professor Richard Stephen, can you hear us? I think, do you have any comment?
Yes, I can listen to you. Yes.
There is public demand for your comment, please.
I beg your pardon, but I was not concentrated when the comment came. If you could reply it, I will be grateful. Because I was speaking on the telephone, that came an external call exactly during the intervention. I'm sorry for that, but it's the pandemic time.
Yeah, so this technology, yeah, these barriers are still there. We can't help. Yeah.
So he is requesting you to repeat and explain the question to him so that he can respond. Sir, please explain.
Yes.
Oh, sorry. Yeah, sorry. I think I thought you were referring to your presentation at that time. Okay. Yeah, we could not see you. Now we can see you. So yeah.
Yes, you can see me. Yes.
Yeah.
What's the point?
No. The question is basically because it is BRICS conference. We are all different universities in all these countries. So how do we enhance our interaction? Maybe to start with, especially on this topic, e-mobility. That is number one. Number two, second point that is discussed is, do we have to keep it as e-mobility, or do we have to also, because e-mobility encompasses several topics, whether we need to do topic wise? So one of the suggestions, of course, is after the discussion from at least three of us. So the opinion is that we need to keep it as a whole, as a single unit, so that everyone learns from each other, because these are all interconnected, though we may not understand the exact nitty-gritties of the subject. These are the 2 points, Professor Stefan.
Yes, there is no doubt that the cooperation between the countries from BRICS is extremely important, because we have common problems. And as we saw during this conference, there are a lot of common problems that we can together try to find a solution. Perhaps you have the emails of everyone that took place in this conference, and we could try to maintain the connection between us. But in any case, if there is no support for a common research work, everything will be like a dream. We need to have money to support common research work, or at least the exchange of students between our universities. But without this financial support, I really do not believe that we can go forward. If I compare with my experience that I had in Germany, at that time there was the German government gave money through the Deutsche Akademische Austauschdienst to have students working and studying there. If not, it's completely, I believe it will be impossible to establish this cooperation. What we saw during this meeting, these 3-day meetings, is that we have common problems, that we are all researching to find solutions for these problems. But how to really cooperate, to turn these ideas into reality, I believe that it must come with some financial support that will allow at least exchange of students to stay part-time in another university. And to start, my suggestion now to start is to maintain this group together through this list of emails. I do not know if my comments are enough or...
No, they are very good. Yeah.
Goes for your invitation.
No, thank you. Thank you, Professor Stefan. Thank you very much. So yeah, in fact, as you are aware that in India, most of the cities, we are implementing these metro systems. And we actually keenly heard your presentation on maglev, superconducting maglev. So yeah, maybe those kind of systems, there is a place in India in the current implementation. So there may be a right situation, context where we can implement such systems. So we actually need to interact and learn more about such things. So that happens only through interaction. And one point that you suggested is about the student exchange. I think that is already on. There is a very good channel that is established. So we can easily do that. Yeah. So
do you have scholarships for these students? This is a problem. For instance, if someone from India want to come to my university, I do not have support to maintain him. In fact, presently, I do not have support to keep my students for master or PhD degrees. And this is big issue. This is a big issue.
Yeah.
We need scholarships.
Okay. Yeah. So I think we can work on that. I think we can. Yeah.
If you can, it's fine. I do not know. At least I do not know any program that will help our interaction.
Okay. Yeah. So I think I also now, with these points, I think now we have reached to the end of this session. So now I think with all these points, our Professor Amit Agarwal, our Dean of International Relations, will also respond. And I request Professor Agarwal to now take over from me.
Yes, thanks, Professor Rao. So one thing that Mr. Stefan was mentioning about student exchange, I think under Brics, we are still seeking funding from our respective government. But I think at institute level, I think that's another sort of direct agreement that can happen. So if we find synergy, if we find that something better can be done, that's it could be possible to have some sort of MOU.
Amit, you are not audible properly.
Okay, I will just remove this. So so we can have institutional level agreements or MOUs which would allow for student exchange between institutions, because we have already seen that there is possibility to synergize the effort. We would definitely be seeking help from the ministries or giving us some dedicated funds for this Brics network. So that's what can be done. Approaching the ministry as well as looking at funds for furthering this. And I also see somebody from China here. I don't know if he wants to make comments. Thank you from NCW. Or maybe you want to their comment also.
Looking from someone from China? Is it anybody?
From NCWU, I think that's a Chinese from China. The person signing in from this account, can you please identify and want to say something? Go ahead. Similarly, if there's somebody from Russia or from South Africa.
No, I think
I request for sharing Bhutia. Do you want to say something? Professor Bhutia? Dr. Sharing?
I think it was a wonderful conference, and number of issues were raised. It was very specific on electric mobility, and I am not specialist on that, but I think the basic idea of coming together for this conference is to enhance cooperation between the Brics countries, and not just this particular topic. There are a range of 6 priority areas in Brics Network University, and I think we have to see how to also engage all the other member universities from all the other all the priority areas. So that's one point I wanted to make. Otherwise, I think this particular I think it's the first time in the Brics Network University conference that we've had such a specific issue. So I think this particular session right now in the end is also an opportunity for us to discuss how to take forward this Brics Network University concept forward, and something that was established in 2015, and we're already 6 years now, and we're still discussing how to enhance mobility. And especially in this pandemic situation, there are a lot of opportunities, I believe, because maybe not physical mobility, but even through online virtual sessions, there can be a lot of interaction between the 5 countries. So there are opportunities, and the Indian government is already putting in place a lot of mechanisms to enhance cooperation. The UGC, which is the University Grants Commission, has also put in place, and there's a lot of discussion now in putting in place credit transfer mechanisms, mutual recognition of qualifications. So these are issues that were a hindrance earlier, but now there is a lot of scope, and I would also call upon all our member countries from other countries, the universities from other member countries, to look at actively cooperating. And I think our international thematic groups in the Brics Network University need to be very proactive in taking this forward. And I'm very happy with the IIT Bombay's initiative, which is the national coordinator for India. And we need to do a lot to take this concept forward. And like Professor Stefan emphasized, there are a lot of common issues that plague our countries in so many ways where we can cooperate. And there are opportunities there. So I think there is a lot of scope. So that's all I have to say. Yeah, thank you.
You want to say something to what Dr. Shering has already said? Mr. Stefan, you want to say something?
Yeah, please. If I want to say something, I believe that we need a fund with some US money, that will allow us to exchange students. It's not necessarily a lot of money, but what we need to start something. Without this initial financial support, I believe it's a dream. It's just a dream. We will do nothing. But I also do not know how to raise this money. I have no idea on that, because I must say, nowadays I'm just trying to turn this prototype that I presented on the first day into a commercial product. Is what I'm doing all my days. It's just this effort. I'm not involved with the university administration or other subjects. Therefore, I'm not the man that knows how to raise this money. In fact, I'm here because my colleague Otto Correa invited me on one day before the conference. I was not aware about that. And then I had the pleasure to know Professor Amiti. And then I wrote to my old friend, Professor Gandhi Rao, and I was very happy to meet him. In fact, my Master of Science advisor was from India, Professor Shankar Prasad Bhattacharya. He is now in the United States, but at that time he was in Brazil. And then I have never visited India, but I have at least 3 good friends from India that I met, one in Brazil, the other in Germany, and the third one in England. It's interesting. Let's see. I'm looking forward to the opportunity to send a student of mine to study in India or to receive someone from your country. It's my feeling now. Is what I think would be our plans for the future.
Okay, so thank you, Professor Stefan. So, are there any other comments, or are we ready to close this conference? From anybody else?
Yeah, just one thing, Professor Agarwal, if you could circulate a list of emails to all.
In fact, the book of abstracts already has the, all the participants. We will be sending that again through email.
Oh,
so you can have, so that way you have all the information about all the participants who were there for the last 3 days.
Right. Thank you very much.
Yes, I just,
it was great.
1 second to formally thank everybody, and then we will close in another 2-3 minutes. So let me, I think we had a wonderful session, a wonderful 3 days of listening to talks and presentations from, the talks were extremely well done, and most of them were very accessible. So I would like to thank all the presenters for doing a wonderful job, excellent presentations, and the session chairs for keeping all the sessions in time, moderating all the questions. So I think I thank the session chairs as well as the participants. We always had good participation in all the sessions. So the participants also need to be applauded for staying there and getting engaged, asking questions, and so on. So I would also like to thank the Honorable Minister, Mr. Nitin Gadkari, for giving a very interesting, for giving the plenary talk and then sort of charging everybody and saying that we're happy to take technologies from IITs and other institutes into practice. So that was very nice to hear. And then we had very interesting comments from Shriya Gadkari as the Honorable Secretary for Higher Education. And then we had our director, the IT Bombay, Mr. Subhashi Chaudhary. I would like to thank him for his time for coordinating that session, the inaugural session, and giving his inaugural talk. And then I would like to thank all the people who were actually behind this conference. I would like to name them, and please bear with me for a minute. So I would begin by thanking Chandrika Naik from the IR office, who was actually put a lot of work behind it. And then Tanvi Mehta and then Shushma Jagtal. So these were the 3 people who were actually behind organizing this conference. And then the PRO, Falguni, for giving wide publicity to this event, the director's office, the CDP office, and the computer center person, especially Mr. Ashish Nagwekar. So Ashish is the one who actually set up everything in the Cisco platform and made sure that everything was, there was no issues. And then it was for the last 2 days, it is being run by my 2 students here, Anirudh and Upendra. So I would like to thank them as well. So I think overall, I think we have some things to take home. I think the discussions also brought out, especially the need for, so I think what was recognized is that there is a potential for exchanging students. And I think everybody is looking for funds. We need to approach our individual governments to sort of make these funds available. And I think as a Brics and network universities, we should be, at least I think looks like the universities are ready to exchange the students. I think it's only the availability of the funds that we look forward to from the ministries. And so I think with these words, I would like to thank all of you again so thank you, good night, and stay safe. And we had a wonderful conference. Thank you. Bye.
Bye, everybody.
Bye.